Assalamu alaikum, ladies and gentlemen. Welcome back to another live stream. Alright, let's see if this is working. Excellent connection. Okay, let me copy the stream link. Okay, I think we're all set up. Great, let me pop out the chat and we can start. So this is a new concept that I'm gonna be doing. I'm gonna be picking one of you guys and basically trying to teach you some Rust. If you are new to programming completely or just new to Rust, you're welcome to join my Discord server, and you can DM me with hopefully a sample of your microphone, and there you go, and we could maybe make a video live stream together in the future. Anyways, so today we have one person with us. What are you called again?
Hello, Behruz.
Okay, well, can you introduce yourself, please?
I'm Behruz. I live in the UK, and yeah, I know a little bit of C++, but that's about it.
Great. Okay, so I guess let's start already. Let's go. So we're gonna be using VS Code with LiveShare. So LiveShare, where is it? There. Okay, great. Let me start up the session. LiveShare. I'm gonna create. Okay, there you go. Let me copy that up. Okay, so Behruz already have LiveShare extension on, so I'm just gonna copy to him the link to my session and he can join in, and we're gonna be on the same Visual Studio Code instance so we can collaborate together. Okay, now I'll just wait for him to join. Okay, he joined. Great, lovely. All right, so we have one participant here. Maybe we should try honestly to do a collaboration with more people sometimes in the future. That would be fun.
Yeah.
Anyways, so where to even start this? Let's see. Okay, so I'm gonna share with you my terminal too, hopefully. Let's see. Make read write.
I got it.
Okay, great. So let's start. So we're gonna start from creating a new Rust project. So cargo new. Yeah, and then name your project something.
Okay, let's say live Rust.
Cool. Enter. There you go. You have created a new binary application, live Rust. So now go to that directory because when you have made a new project called live Rust, you made a directory here. So cd live Rust to change the directory to there. And now, oh, I guess it would actually, can you actually open a folder here? Maybe you can't. So let me just do it manually. I'm not sure if you can do that, honestly. So I'm just gonna do it for you, but yeah. There you go. You're still in the session, right? It didn't kick you out, right? I think it did.
I think it did kick me out, yes.
Yeah. Okay, good. Let's just copy again. Okay. Vortex, welcome to live stream. How is it going? Why am I watching a coding live stream 2 a.m. What am I doing with my life? Alrighty, let's go. src main.rs. Alright, you have joined. Great. Ooh, so now nice. I can see his cursor and he can see my cursor, and we can do stuff in this instance. And he also shares my terminal, but hold on, let me make sure to give you access to that too. Share terminal, read write, and there you go. Great. All right, so this is your hello world. Can you run this project? Cargo run.
Okay, cargo run.
Great, and this is your hello world program. When you create a new Rust project, it automatically gives you hello world as a gift, pretty much.
Nice.
So, can you see my cursor, right? I guess you can also see what I select, right?
Yeah.
Great. Okay, so we have here a function. Since you're already a C++ programmer, I'm not gonna go into much details into this. Yeah, this is the main function. And here we have a call. This is a macro. Println is a macro. And we're calling that macro with hello world. Pretty simple stuff. Alrighty. So, can you create a variable? So, remove that print line. Let's start simple and then crank up the speed. Let and call your variable something.
Okay, let x
equals. Give it some value.
So can I decide
whatever,
what
yeah,
variable type it is? Okay,
Yep.
okay. I can just say hello world.
And a semicolon.
Is there a semicolon?
This is not a Python. Okay, so do you see the inlay hints of the type?
No, I don't touch.
Okay, make sure to go to settings. And make sure search for inlay hints.
Inlay.
And make sure it's on, or even better, maybe on unless. Well, let's just go with on. On.
I mean, it was on already.
Alright, so do you see stir? Reference stir?
I don't, but if I hover over it, it shows me this.
Oh, you don't have the extensions yet, my bad.
Okay.
Go to the extensions, look for Rust Analyzer extension. Oopsies. Rust Analyzer. That's the LSP of Rust. Just install that, and you can also install some other. I personally like to use error lens. It basically shows you the error in line if you don't have that already. It's not required for Rust, but it's something that I can't live without if you don't have it.
I see, okay.
Do you have it, error lens?
I just installed it as well.
Great. So even better toml. This is for toml, which is used for the build system of Rust that I'm going to show you in a second. So even better toml. Let's call it even better toml.
Okay. I installed even better toml.
Okay, so I think that should be it for now. There is some other things, but this should be fine, I guess.
Okay.
Okay, so now can you see the inlay hints and stuff? Maybe you have to restart.
See the errors. Maybe.
Try restart.
If I close the file, let's see. No. But if I restart, I think I have to open the linking. Let's try again.
Okay, there you go. You joined.
Yeah, it's not showing me the hint, but I mean that's not an issue if I don't know, it's not super necessary because I know.
Okay, can you share your screen so I can see?
Yeah, of course.
Watch stream. I see. Interesting. I'm not sure why. Can you go to the settings? Just make sure that is.
Sorry?
Can you go to settings?
Settings, yeah. Settings.
Inlay hints. Okay, it's already enabled. I'm not sure why that's the case on set. But anyways, so fine. Okay, let's go back.
Yeah.
So this is how you create a variable in like C++. Well, actually, the newer C++ have auto keyword, right?
Yeah, they
Well,
do have auto, yes.
So let, you can think about let in C++ just like autoconst.
I see, yeah.
That's basically it.
Autoconst, okay.
Yeah,
So
it
it's
infers the
always
variable.
constant.
And in like
I see.
C++, where mutability is by default,
Ah,
right? But in
it's
Rust, it's
default.
immutability by default. So everything is const by default. And everything, like all the types are inferred by default, unless if you explicitly type them out. Unless if you say here, oopsies, or like this. Now I explicitly typed out the type, basically.
I see, okay.
Cool.
That makes
So
sense.
you have just made a string in Rust right now. Okay, so what we should do next, maybe, can you print that X to the console?
Yeah. Print, was it print ln?
Yeah, because it's a macro, that's why we have that suffix, that exclamation mark.
Yeah.
Okay, so format argument must be string literal. That's the syntax error. In like C++, where if you have done something wrong, it can throw at you a wall of errors that is like an incantation of some dark magic, especially in templates. In Rust, the compiler is really your friend. It really has some very good errors. You can say cargo R instead of cargo run. First of all, save. Make sure to save. Control S.
Okay. Yep.
Okay, cargo R.
Oh, okay. I see. It says you might be missing this.
So you see, I don't even have to teach you that. The compiler already tells you what's up.
Yeah. So if I do this.
And by the way, in the newer C++, C++23 have print line function actually, finally. So you just say something like, if I remember, std print line, oopsies, just like this. And you could just say this. This is how you do it in newer C++, the final C++.
I see. Yeah.
So you have format strings and stuff. Cool. Can you run this now?
So that would be cargo run.
Yeah, just cargo R, but it's fine. And no start of token.
What is that token?
Yeah, probably have some. Yeah, good. Control S. Hello world. Okay, great. Now let's say you wanna type in hello world, like make another variable of type and give it some numeric value.
Let's equal, oops. Something happened here.
It automatically formats the code. Just make sure to put a semicolon.
I see. Okay. Semicolon. Okay, there we go.
I cannot live without auto formatting. So here's one difference between C++ and Rust is the fact that the community is really together when it comes to Rust. In C++, where the community is fragmented. So like we have one build system, which is Cargo, the official build system.
Yeah.
We don't have CMake, Ninja, Make, and so on. We have only one build system. And it's pretty easy to add libraries. I'm going to show you in a second. And also we agree on one code style. So like you could pick up on any repo, Rust repo, and you probably find the same code style everywhere because we use Rust FMT, which when you install the extension Rust Analyzer already came with it basically. And what else? We even agree on some libraries although it's not officially made. Like for example, we agree on log crate, which
Okay.
is basically like an interface for all libraries that wants to use login and wants to implement login.
I see. Okay.
So basically, the community is really together. While in C++, for example, like someone is using C9, C++ with like C++ as C with classes. Someone is using C++ 99 or I don't know what. The other is using C++ 23.
Yeah.
So it's wild, right? It's the Wild West.
Yeah. It is
And
a Wild
everyone
West.
is making his own thing because apparently installing a library is not an easy task when it comes to C++, unless if you have seen my CMake guide.
Yeah.
It makes it
The
a
CMake
little
guide
bit
was
more
fantastic.
tolerable.
It does.
Uh, but we don't do that here, right? So that's great.
Yeah.
Anyways, so maybe say X, and after I want the number after a space.
Okay. So would I be making another
Yeah,
one of
just
these?
try your guess and see what the compiler gives you.
Let's see. Yeah. I would say none.
Great. Okay, try it out.
Assume. That makes sense.
All
Yeah,
right,
it does.
nice. Yeah,
Okay.
so that's how you do formatting in
I see.
Rust. So,
So for the number of arguments that you're passing in, you would have curly braces.
ordered.
Yeah.
And otherwise,
see.
instead of doing this, you can actually also put the variables inside the curly brackets. So remove those arguments,
can,
x
okay.
and num,
Yeah.
and just put directly x
put
and
them-
num, just like Python, kind of, not exactly. So cargo r, yeah, and there you go, same
Nice.
thing.
Okay.
That's why it's a macro, but you can actually do it yourself. So let's actually do it ourselves using std out. So remove that print line and say let std out. Don't save after until you write some line.
Wait, I think, let me just disable. I think I might have the autosave extension.
Yeah, I mean the autosave is
HTML
actually good.
development.
It's actually you just gotta get used to it. Anyways, so just get a new line.
Save typing. Sorry, just a sec. Yeah, it was driving me kind of insane. I was like, okay, so std.
Oops, let.
Let actually isn't letting me. It's hilarious. Okay, let. Okay.
Yes, std out.
Yeah. Out.
Equals
What?
stdio std 2 colons for the, what is it called, namespace something, I don't remember the name exactly. Anyways, stdio another 2 colons. What it does give you right now, I guess std out is there in the auto completion or something. There you go. Okay, so semicolon. Okay, so now we got the std out handle. Alright, so let's go to the next one. We gotta make a little, well, check out what are the functions are available for you for std, or actually yeah, just go ahead, check out the functions that you have there. I think you have read buffer or something like that. Okay, let me remove the auto save maybe, because it's driving me
out of the live chat.
What?
Sorry.
How?
I don't know why, but like it somehow dropped.
Maybe because I entered the settings. Format on save. Okay, I can remove that.
I'm back.
Maybe now it would work. I removed it.
Yep, I'm out. There we go. Yeah.
Try it now.
It looks like it's not auto saving again.
Okay, cool.
Out. And is it dot again? Okay.
Okay, so what functions do you have? I think you have read buffer maybe.
Let's see. Read. No, I don't have read buffer.
Interesting. Okay. Let's see the documentation. Rust docs std out. What? Oh, my bad. I was thinking about stdin for some reason. My bad. So go with write all, right all.
Oh, yeah.
Write all.
Oh, there. Right, all.
Yeah, so what type that it expects?
So it expects of, wait, semicolon.
Not sure why it doesn't give me auto-completion myself.
Yeah, it doesn't give me IntelliSense either.
Oh, what? Let me see, hold on. Okay, there you go, right. All? Okay, so it's a buffer.
Ah,
It's a slice. You know slices? Like you know C++ string views and views in general?
oh yeah, yeah. I haven't worked with them, but I know about them. That like they're essentially a view to a part of memory, a memory location.
Yeah, so they're just basically a
Yeah.
double point, or is it called that? But yeah, it's basically a pointer with a length. That's basically
I
it.
see. Okay.
So
Yeah,
right here, this function write all is expecting from you a slice, which is like a view in C++,
okay.
of u8s
Okay.
of bytes,
Okay.
basically.
8
So
bytes.
we
Okay.
gotta make some buffer, but we want to actually write some string. Is there another function, by the way, for that? Oh, we just say b. Okay, cool. So just type in hello world inside of the buffer instead of buff.
Okay.
Of course, string.
Oh yeah. Oh, world.
Okay.
Okay. And semicolon.
So it's gonna give you an error. I know why, but
Okay.
check it out. Cargo R. See if the compiler would actually help you in here. Huh. It worked.
It doesn't. It does work, yeah. It seems like
Weird. Okay, can you do a new line after
new
hello
line.
world? Because I think it's not flushing, maybe? Maybe we should actually lock it or something. Yeah, we should actually lock it to get the handle. Yeah, my bad. Okay, so say let handle before the write all. Yeah, there you go. Let std out handle, or handle, yeah, it's fine, is equal to std out dot lock. No, std out variable, yeah, dot lock.
I see. What does lock do?
To be honest with you, I'm not sure, but I think it's probably something to do with the multi-threading of terminals. So you have to take a lock first to make sure you don't, like if you're using multiple threads, I believe. But we could check out documentation actually. Though I never really used this myself directly. But it's good to know how that works. Channel is reference to shared global whose access synchronized. Yeah, it's basically for multi-threading.
I see. Okay. So it locks it so that nobody else has access while you write into the buffer.
Yeah,
and
each handle returned is a reference to a shared global buffer whose access synchronized via mutex. If you need more explicit control over lock-in, see the std out lock method. Yeah, pretty much locks this handle to the standard output stream, returning a writable guard. This lock is released when the return lock goes out. Yeah, like multi-threading is going to be very interesting once we get into it. But right now, let's just keep it simple. Okay, so we got that. So can you cargo R?
I think it expects a variable, a argument.
And it helps you already. Let's go.
There we go. I see. So it says consider adding a leading B. Oh. Oh my god, that is actually so helpful.
You see?
It's already so much better
the
than
compiler
C++.
is super good. This is not C++.
Oh man. Okay, so it says,
so what now?
Mute std.
Gotcha.
I see, so std out has to be mutable.
Yeah, why? In your opinion?
I have actually no clue.
Because you gotta write to it. You're writing to it. Like when you write to a buffer, it's gotta be mutable. You know, you have to be able to change it. Because in Rust, by default, everything is constant. In C++. So like you see, in C++, everything is dangerous by default. In Rust, everything is
I
saved
see.
by
Yeah.
default. That's how it works.
Yeah.
Okay,
That's
great.
actually really cool. I like how helpful the like compiler is.
Yeah.
In C++, you get 700 lines of, oh, sorry, you
Especially
have
if
a
you're working with
problem,
templates,
no
yeah.
issue.
All right, so can you remove the... okay, so what warnings do you have? Do you see warnings?
No, I think it just runs. Yep, it did
Yeah,
just
it does
run.
run, but there is warnings.
Yeah, there's warnings. Yeah, it says
Yeah.
unused variables, a bunch of them, and then there's a
Let's go one by one. So the unused variables, you can remove them. We don't need them right now.
yeah.
Oh, hold on. Actually, we don't really need the handle, by the way. It did work, right? It did print hello world. Yeah, we don't
Yeah, it
actually
did
need the
print
handle right now, at least in our case. So yeah,
Okay.
just remove it. Remove it completely.
Okay.
Remove them. So we keep things clean. Num x. Yeah, great.
Okay.
Control S. Okay, so what other
Yeah.
warnings right now you have?
So it says unused result that must be used. Okay. This result may be an error variant.
So what do you think it's saying here?
Hmm.
Just let me your best guess, basically.
Okay. This result may be an error variant which should be handled. Warning.
Can you
Unused
check
loss.
on the signature of write all function?
Oh, let's see.
What does it return?
Ooh. Okay, so it returns an error of find interrupted.
No, just like the signature of it, like what it returns. Doesn't it return an IO result?
Oh yeah, it does return IO result.
Yeah, so basically in Rust, we don't use exceptions here. Exceptions are bad. We use
exceptions are bad.
we use like
I see. So that
yeah.
arrow is the output, like essentially return type.
Exactly, yeah.
I see.
So it's like in modern C++. In modern C++, you would actually write main like this. Auto main.
Yeah,
int.
arrow, yeah.
You would actually write it like this in modern C++.
Yeah. Yeah.
This is how you write it in
mostly written C++ 14 and 11.
in old C++, of course, you would do it like this.
Yeah, you would do int, yeah, and then delete all of those, yeah.
Well, errorlens type an esafe, use it with C++. Yeah, I have a way to actually make it less annoying for more experienced programmers. But right now, we really want to keep the warnings just for now, since we're just starting out. But later on, so in use result, what it's saying basically is that this write all function is returning a result, but you're actually ignoring it. We don't ignore results because it could be erroneous, and that's not great if you ignore some potential error. So if we want to just crash, if we just want to crash if the error happens, we have to explicitly tell that to the compiler by saying .inwrap.
Okay, so .unwrap.
Exactly.
I would crash the program if
so you're basically inwrapping the result value into its output. In this case, write all doesn't return anything. Like you see the IO result, like the signature of write all, it returns an IO result, and there's a generic inside of that, which is a unit type. That unit is basically void in C++.
Yes, yeah.
So nothing. That's the actual result. There's also an error variant, an error generic type, but it's not there because that's a special error type. It's, well, not special, but like, I don't know how to say it, but it's IO result anyway, so whatever. Okay, so this should work now without any use live should have. Okay, what else it says to you there? There's one more warning at the top, I think.
So the top one, it says create live Rust. Have a snake case name. Oh, so the folder needs to have a snake case?
No. Now let me introduce you to the build system. Can you go to your files explorer, right, in VS Code? So which files do you have there? Can you tell me?
So I have main.rust.getignore and cargo lock and cargo toml.
Okay, can you go to cargo toml?
Cargo toml.
Great.
Yep.
So
Okay,
what you see there?
So the package is live Rust and the version and edition and dependencies.
Okay, so here in dependencies, you basically type your dependencies. It's that simple.
Yeah.
Any library that you want to add there, you just type it out. Like
That would be
library
nice
is
if we
equal
added that
to
in.
some version of the library, and that's
I
it.
see.
Done. Done.
Interesting.
Nothing crazy. This is not CMake.
This is
That's
not
it.
okay.
And also
You're
you
taking your
have
shots to C++ as much as you can now.
exactly. So this was supposed to be for a non-programmer, but since you're a C++ programmer, I'm gonna take my revenge.
Just make fun of C++ as much as you can.
All right. So you have this package table. This is kind of like well, a table. It's like a hash map. So you have properties like name, version, edition. And there's also some properties that are not mentioned here, like authors and stuff like that. But we don't care about that. So you can change that live Rust to some other name. Like remember when I said that the community is together? They share a lot of stuff, like how you write your the code style. So even the naming, you see, it actually tells you to better use what is it called? Snake case. Yeah, for the name.
Yeah.
So try to use snake case there and see if it fixes.
There we go.
R should be snake case. Okay, try to cargo R.
There we go. Yeah, no errors.
There you go, that's it. Go back to main RS now. Let me actually follow you even. Hold on. Live share. Follow parties. There you go, cool. So, okay, great. So we don't have any errors anymore right now. Great. So now, just so error warnings doesn't annoy us, I'm gonna add something that a lot of people doesn't even know. I'm gonna say allow dead code and allow, hold on, this is taking out my vision. I'm gonna follow. Okay, good. So did allow dead code and allow, what is it called, in used. But I'm gonna make sure to forbid, not even warn, forbid in used, must use. So this is basically, I'm not sure what they're called to be honest, but they're like file attributes, kinda.
Okay.
So without the exclamation mark, they wouldn't be file for the whole file. It would be just for the next expression in the Rust file. But since I have exclamation mark, it's actually for the whole file. But basically what I'm saying is I'm allowing dead code and I'm allowing in used stuff. So it doesn't warn you anymore on that, but I'm making sure to forbid in use must use. This is by default warn. I'm actually forbidding it right now. So it would be a hard error if that warning happens. So in used must use is like, for example, if you don't use a result, you would actually error, basically.
Yeah, I see. Yeah.
Okay, great. So what do you suggest we should go to next? Let me std out, right on. Okay, let's say we want to generate maybe I should show you some iterators. Let's say we want to generate 10 numbers, like 10 integers, okay? So how are we gonna do that? Can you remove that code inside main right now? Don't need it anymore. So okay, let's see where I'm gonna go with this. There's a lot of ways to go about this, of course, but let me think about it. Let numbers. Okay, say let numbers is equal to, and we can make an array. Yeah, sure. Make a what they're called brackets.
Okay.
And inside of it a semicolon. Yeah,
Semicolon.
good. Now in the left, the type of elements in the array. Let's say let's say U32 or U16 or whatever you want. Doesn't matter. Okay, so basically that's how much bits in the type.
Okay.
And U is in signed.
Yeah.
The signed variant would be I32. Anyways,
Okay.
and there you put the length.
Ah, I see.
Let's say
so
10,
let's say
for
5.
example, or whatever you want. It's fine.
And semicolon?
You have already done it. Yeah, on the right of that semicolon, you say the length.
Okay.
Type in the length, yeah. Whatever length.
I have typed it, like, I don't think it shows it for you, but I have already done it.
Oh, why? Interesting.
I think the live share is being slow or something? Oh, it says connection lost. Reconnecting to host.
It didn't show me that it disconnected, which is interesting.
Well, let me try maybe.
Maybe I'm gonna try to remove you and then you can reconnect. Yeah, I removed you and then you can reconnect, I guess.
Okay.
Okay, let's go.
Let's try again.
Did it work?
Still saying no. It says joining collaboration session. The live share host is currently offline.
What? Let me try to.
Are you offline currently?
if I am, Discord wouldn't work. I'm still streaming though. Let me actually restart this. Hold on. How do you restart this? Let's see. Live share. Okay. How do you? Oh, there you go. Okay. Let's go. Now let's share read write again. Okay, try again. Well, let me copy again the thing. And there you go. Try now. Should work now, hopefully.
Hopefully. And it's
there you go.
Oh, there we go. There we go.
All right.
Yeah. So 10.
Great. Semicolon, right?
Yeah.
Semicolon. Good. Now try and see what's the error that it's given right now. Expected value
says
found.
Expected value found built-in type U32, not a value.
Oh yeah, my bad. Instead of the type, make some value to type. Just say whichever value. Say 0, for example.
Oh, okay.
That's basically the value that will be filled. Now, one thing in Rust, it have safety as a priority, so you cannot have arrays initialized.
Okay.
I mean, you can, but there's another interface of going about it, and it's more explicit, more safe, you know.
I see.
So like the thing is, we do have unsafe code in Rust, but you localize it into some places, right? So for example, the standard library would be full of unsafe code, but it would be in one block, and if anything fails, you know exactly where to look, basically. Instead of C++, everything is unsafe, right?
Yeah.
The stakeholder could be anywhere.
Yeah.
You never know.
That's true.
All right, so now you're basically creating an array of 10 elements with 0 as the default value. Well, not as a default. Well, that's basically going to be copied for every element, right, into the array. Great. So can you try to print that array right now?
Okay, let's try. And we can just say numbers and semicolon. Does that work, or do we have to do an iterator?
Just check out with the compiler. Just check out with the compiler.
I think you need to share terminal with me because I don't have access to the
Oh, I
terminal
see.
anymore.
My bad. Sure,
No worries.
read right. Okay,
Yep,
now it should
there we
work.
go. Okay, so it says format argument must be a string literal. You might be missing a string literal. Oh, I see. I remember that.
Because like interpreting, because I'm not gonna be here forever to teach you, you know. So, like learning about format, like the compiler errors and stuff, and how to talk to communicate with the compiler is very crucial skill, which not a lot of tutors would actually do. But here
That
we
is
go.
true.
Especially for a new programmer. So
Yeah.
You are not new, but well. Anyways,
New to Rust.
cannot be
To the new.
cannot be formatted with the default formatter. Interesting. Okay, so what it's saying here is that it doesn't know how to format numbers, but because std_fmt display trait is not implemented for that type, this is a little bit of an advanced thing that we're going to cover later. But right now, you want to basically tell Rust to just give me a debug representation of that object. So what we do, we go inside the bracket, not the bracket, inside the curly braces, and colon, interrogation mark. Just colon, one colon, sorry. One colon and then enter. Yeah, there you go. Okay, Control S and try now.
Oh, I see.
Okay, so this is basically a debug formatter that Rust gives you, but it's not supposed to be used in actual production code, right? You're supposed to implement your own thing. But anyways, so what about the tip that I gave you about the argument there? About the format?
The unwrap, or do we put the numbers inside the...
Yeah, go ahead.
The unwrap?
No, remove the numbers. Like the macro doesn't need inwrap. It does it for you.
Yeah.
And just put it before the colon. Before the colon.
Before the colon, I see. Okay. Numbers.
Like before the colon you have the variable, and then after the colon you have some formatting stuff.
I see, okay. Yeah, that compiles the same way.
There you go. Okay, cool. Yeah. So how we can fill this with something? Let's see.
I mean, in C++, I would just say numbers, like, just literally put stuff in here and just...
yes, you can actually do that. Oh yeah, good.
You can.
Go ahead. Yeah. I thought you were gonna do something else, but it's fine. That's also good.
Yeah, mutable. Oh, okay.
Great. Nice. You can also use the initialization syntax. So instead of doing it like this, you could also go ahead and say something like this, you know.
Can you also like leave like... Oh, okay. When you leave 4, it will just make you like array of 4. I see.
You can also leave a leading comma afterwards.
Okay.
And this is good for formatting. If we had the auto formatter on, that would be great. But it's fine for now. Okay, let's go back to what it was for now. And actually, we need some for loops right now. Just try to give a guess, you know, from your C++ background, and then we can, you know, go about it with the compiler.
I just used the auto
snippet.
Okay, so
snippet did it for you.
Yeah.
That's good.
So for num in numbers.
Okay.
Wait, actually, I can do this. Ins line. And here, I can just put num. Let's see if this works.
Okay.
It would be interesting if it does.
There you go.
Oh,
so
cool.
You basically printed every number, right? You don't need though the interrogation mark in this case, but it's fine because we're gonna need it later. So let's just keep it.
Yeah.
Okay, great. So now what about you want to like go iterate through and mutate it?
Iterate through and mutate.
That's a little bit hard. So you can initialize it basically like you would make an array of from 0 to 9, inclusive.
Yeah.
So you initialize it through those numbers.
So it wouldn't be with this for loop, because this for loop, I don't suppose it allows you to mutate num.
Yeah.
Would it?
True. Because why? Because it gives you an i32, which is basically just a...
Can I just do mute? No, I can't do it.
Okay, let me see. Hold on. Well, basically you need an index, right? We're just gonna start simple from the most naive solution. Then we're gonna, keep on going from that. So for let's say index in, and in Rust we have a syntax for a range from 0 to 10. 10, of course, exclusive.
Yes. Yeah.
And then do whatever you want to do with that now.
So, in here I can say index equal 25, let's say. I have a feeling that won't allow me to do that though, because...
No, you don't want that. That's just the index that you're going to use on the array.
Yes.
So grab the value right now with the index.
Yeah.
Number is equal to...
Yeah. That number equals to... that would be numbers index.
Yeah, exactly.
Numbers index. Oops. And
there you go. Now instead of num, you just say number.
Yeah.
In print line.
So, yeah. I am thinking that can I make this then just
let's just start from there. Let's just start from there.
Okay. Just by printing it.
Okay, same result, just a different way of doing it.
Yeah.
But now let's think about this. So can we get a reference to that number's index instead of the value itself? We could put like a reference here, maybe.
Okay.
Okay, try now to change that. Dereference it and change it afterwards here.
So...
And just like we would do in C++.
Here. So the way that I would do it in C++, I would just say number... Oh.
You would dereference it first using star.
Give it a star.
Yeah, and then you would equal
something. Let's say 5.
Okay, what it's saying?
Another sign star number, which is behind the reference. Number is a reference, so that data is referred to cannot be written.
You can do cargo R to get more information from the compiler.
Okay, let's see. It said, so let number equal immutable reference. So even the references are immutable?
Exactly. It's a contract in both ways, in like C++, where the contract is only on the function.
That's nice. That's actually pretty cool. Nice.
And it's actually not just a nice thing to have, it's actually required for the borrow checker, because Rust have a borrow checker that makes sure you're using everything correctly. So now instead of number is equal to 5, you can say index equal to index instead of 5.
Yeah. Index.
And you could just take that print line out of the loop and print the numbers array directly. Okay.
So we will get the index printed out.
Yeah.
Essentially.
Okay, so that's one way to go about it. But there is, of course, much better ways. Let's go to the next stage of a better way. So instead of getting an index, so even in C++, if you have seen one CPP-con, I don't remember the name of the author of one CPP-con, but basically row loops are the root of evil. that's how they see it, right? So for loops are with the index is bad. So what you should actually do is always try to go with number in numbers. But the problem that you found with this is that instead of giving you a reference, it actually gives you a copy of the value, because it's just iter32.
Yeah.
Iter2 is a primitive type, so it gives you just a cheap copy, trivially copyable. It's called that in C++.
Yeah.
Anyways, so we could do this, but then it would give us a immutable reference. But we could say mutable reference, and then it would give us a like that, basically. Now we don't need this anymore, and we don't have the index anymore.
I see, yeah.
But we could do something about that. We could say mutable numbers, I guess, dot enumerate. I guess maybe we cannot. Interesting. Cannot do that? Yeah, interestingly, we cannot. Makes sense. Maybe. Well, yeah, but you got the point, right? So I wanted to show you how this works first of all, right?
Yeah.
So this is the same thing, just much more hygienic, right?
Without copying it. Yeah.
Okay, great.
This is like
now the way you would actually do it in Rust. I mean, there's still more steps away, but let's go step by step. So remove that. Hold on, mutable reference numbers. How are you gonna go about this? Let's see. Okay, so let's remove this whole thing right now. Okay, so instead of doing this, we're gonna use iterators, and I love iterators. This is like my favorite part of Rust. Yeah, we're coming to that solution. I'm just showing him one solution after the other, and in the way I'm showing him more things, you know. So, but yeah, cool. Anyways, so now iterators are the most favorite one. In C++, they're called ranges. In the modern C++.
Okay.
Ranges, and there's also iterators, but like iterators in C++ is iterators in Rust is ranges in C++, not iterators. It's weird, but anyways, it's not like one-to-one translation though, but it's pretty close. Anyways, so let mutable numbers. You can say 0. You remember the range syntax that I shown you?
Yeah. So 0.10.
Yeah, good.
Yeah.
Try that.
Yeah. So let's try.
Okay, but you just got a range because that's just a range value.
Yeah.
So how we can turn it into an array? That's a good question. So make into a parenthesis. So wrap it in parentheses.
Okay.
Oops. Okay, great. Now say dot collect.
Collect after the parentheses?
Yes.
Okay. Dot collect. Is type annotation needed?
Cargo R to see more details.
Say. So, okay. So it says.
Just tell me what you understood from the.
Item self required by this bound iterator collected, and also mutable. Okay, so what I'm understanding is that it's saying that first of all you need to initialize that numbers is a vector.
What is the first error?
Yeah, the first error says a form iterator
type annotations needed.
Yeah.
Type annotations needed. Type must be known at this point, because basically what collect does, collect takes any iterable or iterator, and it turns it into a vector or whatever type, not necessarily a vector. You can collect it, like basically 0 to 10 is a range, but you can collect it to a vector, you can collect it to a hash map, you can collect it to a tree, any collection that supports it, right? That implements it.
I see.
So you should basically tell it which what you want to collect it to. So one way you could do it is what the compiler said to you. Try that.
The vector, for example?
In the end, exactly. So here basically you told it to collect it into a vector just by annotating it with that type, and Rust compiler is smart enough to infer what you want to collect to.
I see.
And why we have that instead of type, in your opinion?
I mean,
it's basically telling you, say.
it allows for like generic type, that it allows any type can be passed into the vector?
Yeah, but like we're supposed to pass the vector the type of each element, but why we're giving it that instead of the actual type? So we're supposed normally to say U32, but we're doing this. We're basically telling the compiler you're smart enough to figure it out from the value that we're initializing. So in this case, by default, integers in Rust are I32. If you actually hover over it, you're going to find I32. And so here, you're telling the compiler, instead of me telling you I32, just figure it out yourself from the initialization. That's why we have this instead.
I see.
So we're only the Rust compiler. What it doesn't know is what collection we want to collect to, but it does know the type of each element from the initialization.
Okay.
You see, it's smart enough.
I see. Yeah.
So, okay, cargo R.
Okay. Let's see. Okay, it printed it. I see.
Great. So,
like a normal array.
But the problem though, it collects it into a vector, not an array. Though I wonder if we can actually collect it into an array using iterators. What if we do this? Hold on a second.
Wait.
Expressions can only be used on the left. Okay.
Wouldn't that be like collect? And then it says...
I don't think it would actually work because probably collect doesn't have the information at compile time. So there may be a way to do that, though I don't have it in mind. Is there some other? But yeah, there is another way to do this, which is array from fn, I believe.
Okay.
Creates an array which you shall. Okay, great. So I'm going into a little bit of an advanced territory, not much, but I'm trying to like give you simple examples one by one.
Yeah.
There you go. Okay, type annotations needed for usize n. Okay, it doesn't know the array length, right? So I can tell it to figure out the type, which is okay, and then I'm gonna tell it, let's say 10 numbers. Okay, try this.
Okay, I see.
Okay, there you go.
Okay.
So I'm gonna
let me get this.
Try to okay. Let me know what you learned from this.
So
like what you can.
So you're creating an array, and you tell it to of type figure it out, essentially the underscore, and I'm kind of like unsure of what does those two I mean.
So basically here I'm saying from fn, which is from the array namespace, right? From the std, standard library. So this from fn function uses some unsafe magic to do it, to basically initialize an array safely and efficiently instead of using initialized arrays. Those you can use initialized arrays, but this is a better way of doing it. So from fn, I'm saying that I want to make an array from a function, right? And here I'm passing it a function, and this is basically a lambda. If you're coming from Python, in C++, what is it? I think it's called lambda there too, right? Or closure. In Rust we call it closure. So it's basically in this case from fn, if you see the signature, which is probably quite hard for a beginner to understand, but basically you give it like a generic f, which is a callback. You don't have to understand honestly this yet. I can teach you more later on, but right now basically it takes a function that takes one argument that is of type usize, and you should give it back some t, which is basically the array element type. that's the type
I
that you
see,
should
okay.
give it. So here what I'm doing, I'm
Yeah.
getting the index of that particular element in the array, and
Yeah.
then I can assign it whichever value I want in function of
I
that
see.
index. In my case, I'm just
I
telling it the index, that's the value. And if we don't do this, the compiler would complain that type annotation is needed for usize n. Well, you see
I
that it
see.
figured out that you need that it's a usize type for each element from the function, right? It inferred that,
Yeah.
but it cannot
Yeah.
infer the second generic, which is n, the size of the array. So
see.
that's why I had to do it like this explicitly to tell it how much elements I want in the array. Though I think,
mean,
yeah.
kind of quite understandable, because if you're putting the actual index of the array inside the array, and you're not telling it how long this array is going to go on for, it's kind of like,
Yeah, it makes sense that
becomes
that
confused,
information
because
is missing, right?
yeah. It's like,
Exactly.
I can go on forever, but I don't think you would want me to.
Well, in this case,
That's
it's
your
making an
key.
array, so it cannot go forever. Though with iterators, it can go forever.
I see.
We'll see about that in a second. Anyways, so I think we can rewrite this in another way, and I prefer that
Okay.
way, honestly. I'm not sure if it works. Sometimes it's finicky, but I think it should work. Maybe. Interesting. Yeah, I told you, sometimes it's quite finicky, so let's forget about it. Let's not waste time on that. Anyways, I'm gonna show you that later. It's called the fish syntax, I think, or something like that. Anyways, so right now we got that. Good. Now let's say we want to generate some. So this is understandable, right? So you learned about lambdas. Learn about this from fn function or the standard library. Great. Now let's say we want to generate some numbers. Now I'm going to try to go into the iterators part of it, which is very fun.
I see.
At least for me. Yeah, let's say we said 0 point, right? So here, let's remove that array thing now. So what I did here, range from 0 to inbounded. I didn't give it a upper bound, right?
Okay.
So it goes from 0 to forever. That's the range.
Yeah.
Cool. So let's say we want this number's range to be doubled, like every element in that range to be doubled, and then printed out each element. So how we can do it? Just try to do it with the tools I've taught you so far. Just try.
Okay, so each element we want it to be doubled. So let's say a for loop. We say a num in numbers, and then I can do a reference here. That would be interesting. Let's do mute numbers and then num. How would I remember the index here?
You gotta iterate through an index, or use iterators like I've shown you before. Just try it. Like what you want to do right now. Just tell me.
Well, essentially what I want to do is like to times it by like 2.
Yeah, to dereference it, right?
But I need to dereference it as well. But
you have to do equal times equal, yeah?
Times equal? Is that also possible here?
Yeah, I think so.
This cannot mutate immutable variable num.
Do you get that error too?
Oh. Yeah.
Huh. I see. You know why? Because those numbers aren't actually a array or vector. It's a range.
I see.
So you cannot really mutate one part of a range.
Okay. So I can't use it inside the for loop.
No, you can use it, but you cannot mutate a range. You have to change it to something else. first.
Ah,
Like, for example, a vec.
I see. So do I, after initialization of the numbers, turn it into a vector?
Yeah, you can do
Or-
that. Try it.
Let's see. I actually don't know how would I change a range into a vector.
Basically, wrap that range in a parentheses. Go ahead, remove that. Yeah, wrap the parentheses. Wrap the range in parentheses.
Wrap range into parentheses. This.
No. The actual numbers range, value. This one.
Oh yeah,
Hold on.
this.
This
Yeah.
one.
Oh, that one. I see. Okay.
Wrap it in parentheses, right? And then collect it into. For simplicity's sake, just collect it into a vec. Yeah.
So can I do like this?
Not collect into, just collect.
Okay.
And yeah, but what it needs here, it needs some information. What it's gonna collect to.
Collect. Well, if I pass in here, can I pass in vector?
No, you cannot do that. It's encoded in the type.
I see. Okay.
So
let's.
The number should have a type of vec.
Okay. Vec.
There you go.
Okay.
So now you have a
now
vec.
Now I have a vector. That is the numbers. Okay. So type integer cannot be dereferenced. Oh, okay.
I don't think that's right. Try say cargo run. I think Rust Analyzer is drunk or something. There you go. It's have updated, I guess. Thread main panic capacity.
Oh yeah, there we go.
Oh yeah. Read the error. Okay. I actually intentionally did this so I could teach you why iterators are important.
Oh, capacity overflow. Oh, I see. I see. Yeah, because it runs for infinity range.
Exactly.
So it runs out of capacity for a vector.
Exactly. So you cannot store in a vec. You have to use iterators here.
I'm glad I didn't crash your PC.
No, this is Rust. Once you do something wrong, it just panics, at least in debug mode.
Okay, yeah.
In release mode though, or in C++, it would basically just go on forever and, like wrap back to the start. Or in fact, maybe in C++ undefined even. But anyways. So, okay, great. Now let me show you how you can do this in iterators.
Okay.
So this is, I didn't show it yet, of course. I just wanted you to kind of use your brain there to figure out what is the actual problem we're trying to solve here. So here I'm mapping that range, and then I'm getting the number from that range, which is an iter2, of course. I don't have to explicitly say the type. Rust does the inference for me. And then I could say number times 2.
I see.
Well, what's up now? Missing times expected. Oh yeah, let's remove this vec from here. And now we could just say for number in numbers number. Oh well, print line. Oopsies. Print line. Oh crap. Number. And there you go. Cargo run.
Okay.
Oh, look at that. It just keeps on going forever right now. Unless,
I see.
If I limit it here or here, doesn't matter, right? Well, let's say, for example, here, take only 5 results. Take only 5.
Okay, I see.
You see?
I see.
It gave me what there? Using this iterator? Can you describe it?
Well, using this iterator, essentially you set based on the range's index, whatever the index, times it by 2 and like return it, and then when you're inside that for loop, you're just taking the first 5 numbers of that.
So the first 5 numbers multiplied by 2 or doubled.
Yeah. So essentially, oh nice. Like we have a map in like Rust, similar to essentially functional programming.
Exactly, it's
There.
functional programming there.
Okay. Yeah, I see. That's cool. Okay.
So here we're basically generating an infinite, not infinite, but unbounded, right? From 0 to infinity. We're mapping each number there to number times 2. And now iterators are lazy. In like you see when you collect it to a vector, it said capacity, infinite. You cannot do it. Crash. Because, you cannot just create an infinite collection, right? You cannot. You don't have infinite memory. And you don't have infinite time either, so...
Yeah.
And then here, like... Yeah, that's the first problem. Exactly. The second problem is the fact that when you're collecting into some collection, you're actually allocating memory, which takes a lot of time, right?
I see,
so you have to go ahead, ask the operating system, can you please look for me for some available memory? And then you have to look out its data structures to find in the heap some available memory. Then it brings it back to you. So that's just a lot of wasted stuff. Unless if you really need the vector, you don't need to do it. And here we're just taking 5. I could have done this here too. It's fine. Depends on my use case, right? So here I'm just having the whole iterator in one thing. So this would be actually first. So before this would have been doubled numbers, I guess, right?
Yeah.
Oopsies.
Yeah.
Oh crap, I cannot type today. Doubled numbers, right? But with that take 5, let's say first 5 doubled numbers now.
Yeah.
And this is lazy.
So
it would only work once you actually start iterating through it, or basically consuming it. That's the technical word in Rust. So yeah, what's the questions?
So my question is, can I do take 5 and then put the take 5 before the map?
You can, right?
And then
see what happens.
I can.
Yeah.
Well,
but the order matters, though. Depends on the operation. But try it out. In this case, it would be the same. Cannot find it. Yeah, we just because we have changed the variable name. Try now.
Okay, so it gives the exact. But my question is.
But the exact same thing here in this case.
Yeah. Yeah.
It would be different on some other cases. Anyways, I'm gonna try to find some operation that where the order matters. Let me see.
But I'm thinking, is this?
Let's say
okay.
Let's say hold on. Let's say we want to filter only the even numbers. So we want to keep out only the even numbers. So let's remove this. So I didn't teach you this. This is another function in the iterator called filter. So type in filter.
I see.
Oops. Filter? No. Go back, Control Z.
Whoa. What happened?
The filter?
Filter?
Exactly, yeah. And here a predicate. Okay. It's basically, a predicate is just a closure that returns a boolean. This is in mathematics. So how would we do a closure? This is your first time doing it.
How do we do closure? Was it
2 pipes?
Pipes. Closure was the lambda.
So the argument first. What's the argument here that's gonna get piped to you here? Which is the number that you generated here from the range.
Yeah.
So call it something. Number, yeah.
Yeah.
And now here this is a predicate, so you need to return a boolean. So how are you gonna check if this number is even or odd?
So are we checking for even or are we checking for odd?
Whatever, doesn't matter. One of these.
Okay. Let's say we are checking for even.
Okay.
And number. Where is the 2 is equal 0.
Okay, semicolon, and try it out.
Let's see. And cargo run. Oh. Wait. Whoa. Okay, so we are getting the even numbers. That's correct.
Yeah.
But let's say take
Iterators are pretty much my favorite in Rust, at least.
they're kind of fun. Yeah. Nice. Okay. 0, 2, 4, 6, 8, 10, 12, 14, 16, 18.
Yeah.
Fantastic. So I can this is actually really cool. I like this. I really like this. I like this idea of functional programming.
Yeah, it's pretty fun.
Yeah. Like you can do loads of stuff with just like literally
I think
one
there
line
is
of
a
code.
function already in Number that allows you to do this. No? Let's see. No, actually not. Interesting. Okay, fine.
I mean,
this is
I know
fine.
there is a what is it called? A cargo
Yeah, you can
dependency
always
that you
add
can-
libraries, yeah.
Yeah. There's a
Okay.
library. I actually saw it, like people making memes about it. And the is even library is the dependency is odd library.
Yes. There is a cool math library that I can show in a later video, I guess. Okay, so what should do now? Oh yeah. All right. So here's the thing, I guess. So now remove that tick from there and put it in before the filter.
Oh yeah.
So how much results you're getting right now before you run?
Before we were
Right
getting
now,
10
right
results.
now, yeah, right now, before running. How much results you're getting?
Yeah. 10 results.
Okay, run now.
And it should be less than 10.
Why?
Yes. Yeah. Well, because essentially it runs through, takes the first 10 and then filters it.
Exactly.
Before it filters it, then takes the 10
Exactly.
result, which is really cool.
Yeah. So before the order mattered, like the order didn't matter, but here the order matters.
So from optimization point of view, if I'm calling take 10, I'm guessing the iterator does not generate the rest of that kind of, what was the range? It will only create the ones that I need, because you said
you're
it's
actually
lazy.
you see, with iterators you're not allocating a single thing, of course, other than the stack, you know. I mean, in the heap you're not allocating any memory in the heap. This is just, it's kind of like, you can think about it this way. In fact, in Rust, some iterators works this way, is that these operations that you do here declaratively, which is way more readable and way more flexible, way more composable, etc. Instead of, like, what, let's say, the compiler does is take these and turn them into loops, you know, and stuff. Like, you can actually make your own iterators. And then you actually would understand exactly how this works.
Yeah.
I mean, I think sure we can make some little like the simplest example that we could do. I'm gonna show you how you can create a struct, because that's how you start creating a iterator. We're gonna make a little simple thing that just count up, I guess. Okay, create a struct.
Okay, so a struct.
Call it, I guess, counting iterator, or I don't know, count iterator or whatever.
Sure. Is that good? Is that how you make this struct?
What's the warning there?
It says a structure counting it a camel case name. Oh, okay. I see. Okay. This is interesting.
Yeah.
Okay. Are you happy now? It isn't camel case. Oh, it should be capital C as well.
There you go.
That was Pascal case, right?
Okay.
Yeah. There we go.
So now,
counting it.
Here we can store whatever we want for the iterator to function. We're just gonna store a number.
Yeah. Number, okay.
So
let.
No, without the let.
Without the let. I see.
And with instead of semicolon, comma. And before the comma, you declare the type. You colon and then declare the type.
Okay. I32.
There you go.
Oh, I see. Okay.
Now you created a struct, your first struct in Rust.
Yeah.
Great.
Okay,
So,
interesting.
interesting. I'm not sure how much. I think I'm gonna go with a simpler. Yeah, I don't want to give you traits right now. Yeah, we're gonna go with a simpler way of doing iterators, and then we're gonna go to a more advanced version of it. Okay, so just go in the next line and say impl. No, not there. Outside of the struct.
Oh, I see.
And you'll actually appreciate why it's outside the struct later on.
Impl.
Counting iterator. Impl. Yeah, counting iterator. The same name basically. Impl. No, after the impl.
Oh, okay, I see.
This is called an impl block.
Iterator.
Implementation basically stands for that.
Ah, I see.
So here you can define functions that would work on that struct. So fn.
Okay.
Say next.
Next. Does the naming convention matters here?
Yeah, of course. It matters everywhere. So main.
So
yeah, exactly. There you go.
Yeah.
And then.
And I'm guessing just like this.
Great. So basically, an iterator is just like a struct that contains some information on what is its progress. In our case, it's just a number here, and then a function next. Yeah. And every time you consume the iterator, it calls this function next to get the next element in the iterator.
I see.
That's basically it. Right?
I see.
Okay, so what you're gonna do here? You're gonna say, well, first of all, you need here to specify that you want self, because just using this is a static function now without the self.
Yeah.
Like in C++ where you have an implicit this parameter.
Yeah.
In Rust you don't. You actually have to explicitly declare self. And actually in the newer C++, there is a way to declare explicitly self. And it is actually very useful for templates. Anyways. So basically C++ is just like evolving into Rust, but with more steps. That's basically.
Yeah.
Anyways, FN actually understood a lot of stuff about C++ from Rust after learning Rust.
Yeah. Nice.
Anyways, so fn next, and here what we're gonna do. Every time we consume the function once, what we should do? We should do self.number plus plus. Plus equal 1. We don't have plus plus here. Plus equal 1.
Plus equal 1. We don't have plus plus here.
Yeah. What it's saying?
Mutate immutable variable self. Interesting. So can I just do mute self?
Yeah, but the problem with this way of doing it is that we're passing self by value here.
Yeah, we are passing. Wait, can I do reference?
Exactly. There you go. Nice.
Nice.
Let's go.
Okay.
All right. So, and what we should return? What is the value that we return now?
Wait.
Afterwards.
Don't we need to dereference self?
No, we don't. It's gonna happen automatically by the compiler.
Okay, I see.
Just like C++ when you do this, this operator.
Yeah.
Okay, go to the next line and return what you need to return every time the iterator runs. Return what?
Return just
what this iterator will yield every time.
So yield the next item in the.
What is the item in this case, in this iterator?
Number.
Exactly. So what we should return?
Yeah. Number. Oh, self.number.
Great.
Right?
Yeah. Let's go. But in Rust we don't need the return. Remove the return and remove the semicolon.
Oh, okay.
By removing the semicolon, you're basically returning that value. As long as it's in the end of the block. If it's not in the end of the block, then you have to return explicitly.
Okay.
So what's it saying right now?
It says mismatch type expected an object or
unit.
Like
that's
generic.
a unit.
Okay, unit. but found I32.
What's unit is equivalent to in C++? Void.
Oh yeah, void. Yeah, yeah. Okay.
So since you're not declaring the return type.
Oh.
Okay, can you say
do...
cargo run? See if the compiler tells you something.
Oh yeah, that would be interesting if the compiler is like, yo, you forgot this. Okay, so it says no. It just says expected unit found I32.
But it's telling you where to put it. At least.
Okay, I see.
You're there, yeah.
Yeah.
Let's go.
Would it be the arrow and
Yeah,
then
exactly.
I32?
Exactly.
Nice. I kind of expected this because you mentioned earlier about like this would be the return type similar.
You know
to
why
the
C++
new...
is, instead of like making the return type at the start of the function, now they're leaning towards, like modern C++ is leaning towards, like Rust, making it at the end because of generics.
Why?
Because when you declare a generic in C++, you have to be sometimes you're gonna need that way of doing it. Like, I don't exactly remember what kind of way you go about that, but like some complicated way of using generics. I don't remember exactly the situation. You're gonna need the newer way of doing functions. I don't remember exactly, to be honest. Anyways, fine. FNX iter. Okay, cool. So now this is not exactly a Rust iterator, but this is like the kind of like the semantics of Rust iterator. So we cannot use this fancy functions yet. We're gonna make it hopefully later on, but right now let's keep it simple. And yeah, okay, I'm just gonna comment these out for now.
Yeah.
Now here you need to basically keep on calling that function and printing the result.
Yeah.
So first of all, you need to make an instance of that iterator. How are you gonna do it? Just try your best.
Wouldn't that be just counting iterator and then should be a snake case. Interesting. What?
Well, it cannot name the type with the same name as the variable.
Oh yeah, true.
First of all, and second of all, yeah, the naming conventions. Counting iterator.
Counting iterator.
Use the compiler, see if it can help.
It says use a struct literal syntax needed. Counting iterator number val. Okay. So I need to pass in a number. Let's say 32.
This is not C++.
Oh, I see. Number.
There you go.
Okay, I see.
Okay. The compiler told you pretty much.
Yeah, it did everything.
That's right here,
that is such a blessing. Oh my god, I feel so annoyed that like we have to work.
Imagine I'm teaching someone who's new to programming Python and just gets every time he runs the code, he gets like null or exception or some type. Bruh. Anyways, count it. Yeah. Good. So you made an instance of that struct. Now how you can consume it? Now consume it, get some value and print that value. Let's start simple. Let's just consume it. First of all, make a variable, and the value would be consuming the iterator.
Let's say let single
just like me.
Value. Oh dear. Dot.
Yeah, go ahead.
Next.
Okay, so what's the problem there?
Okay. Says cannot mutate. What? Oh, it's because I see. Because here we are mutating the number.
Cargo R to get more details.
Yeah. It says cannot borrow immutable. Okay, let's mute it. Okay, yeah. I expected this would be.
But try reflects why that's the
necessary.
case. What needs mutable access here?
Well, the number, because when we are going inside the next,
Yeah, the next
we are
function, what it takes.
mutating.
The next function, what it takes as an
It
argument.
takes self.
Self what?
Oh, I see. I see. So it takes itself, the object itself.
Mutable reference
and
to
it,
self, yeah. That's why you
Yeah.
need the count your iterate itself to be mutable first. Then you can use that function that takes mutable self. Right.
Interesting.
So now print that value that you have consumed from the iterator.
Yeah. Let's see. Print. Print the len, not print normally, and that would be this. This. That would be single. You know what? I'm just gonna copy it because I don't want to make a mistake here. Then semicolon. Let's run it. See what we give.
There you go.
83.
Yeah, because
Interesting.
you start with 32. Yeah. There you go.
Yeah. Yeah. Nice. Nice. That's actually cool.
But
Okay.
what about actually consuming more values?
Well, we can put it inside the for loop and just
Yeah,
continue
try.
increasing it, or like
Yeah, try.
just say for single. Oh jeez, single. Since you made a joke about it, I'm just gonna continue using single. In ooh. Ooh, this is actually 0 to 10. Let's say we want to run it 10 times. And this would be index. And we say...
Imagine, going into some company, and of course, tech company. And in the code style, they tell you to not use words like single because you may make someone cry.
Oh dear. So here, because it goes out of scope, we need to move this variable probably outside. Later on use it. Can we have variables?
You cannot have initialized variables.
I see. Wait, let's see. Can I do this? I32?
But why you need that? Just keep it inside, actually.
Well, if I keep it inside, it will
you need
go
to
out of scope.
you need to generate a new value. Like you need to consume the iterator every time inside the loop. If you do it outside, you're gonna do it once. Right? So now you just enter that print line inside of the block.
Okay. But inside the for loop.
Yeah, exactly.
And then
single value, right?
Okay, there we go.
Okay, cargo R.
Let's see. A30. Okay, nice.
There you go. Now we could also do.
That's cool.
Now I wanted to actually show you why we need something, but you have done it. You already seen that coming, I guess, or maybe just by accident you have skipped over that. Because if you have noticed, I actually try to give you the problem first, then give you the solution. You skipped over it.
I see.
Anyways, so another way of doing this would be while, but I didn't show you the while yet, so that's fair.
Yeah.
Didn't know it should. Oh yeah, my bad. Loop.
Infinite loop, yeah.
So you do it like this.
Loop. And that will just go in.
Yeah, try that now.
It won't break your PC.
Yeah, as you can see now, the problem with this is that it's gonna keep on going forever. But there's no way for the iterator to tell us when it's gonna end.
Well, I can do a break. I can just do like But
no, like in the actual iterator itself, because that wouldn't be possible when you create another iterator that would use this iterator and so on. Because you don't know the iterator itself. You're just gonna take a generic iterator. It doesn't matter what the iterator is.
That's true.
So how we could do that? We could actually make this an option. So just like this. You know std optional in C++?
Yeah.
This is it.
But I think std option is C++ 12. 20? Or
Not sure.
17?
Probably 17.
I don't know.
But
Yeah, I think it's.
there's
probably
also
17,
now an
but-
expected, a CD expected in newer C++,
Oh, yeah.
which is basically the
Yeah.
equivalent, almost the equivalent of Rust result.
Ah, okay.
Anyways, expected option I32 found I32. So what's the problem with that? Can you cargo? You see the console output, right?
Yeah.
What's the compiler's telling us?
So the compiler is saying option I32 cannot be formatted with the default formatter. Okay.
Before
The
that.
trait std format. Oh, before that. Okay. It says, oh, I32 doesn't implement std format display.
But no, it did give you a solution even for one.
Oh, that one. Okay. It's because my terminal cuts off. Like I don't see half the stuff.
I
So
see. So
it's
try to run it
yeah.
again. Try to run it again.
Yeah.
Right. Cargo R.
Cargo.
R, just R. You don't need the run.
Okay.
But it's fine. Okay, go on.
So, okay. So it says mismatch typed. Expected option because of the return type. Expected found I32. Then expected enum option. And then try wrapping the expression in sum. Interesting. What does sum do?
Try it.
Sum. Okay. It says sum.
This is a solution to the $1 million bug.
Some value of type T. Interesting. So essentially, it will get the value and return the value.
So basically, option is either some value or none.
Uh-huh.
There's no null in this case.
Ah, I see.
Everything is explicit.
I see.
And there you go. We fixed the null problem.
Uh-huh.
All right. So because the compiler wouldn't let you choose an option without actually unwrapping it or handling the none variant first. So option is basically just like an enum of tagged enum. And by the way, enums in Rust are pretty hot. I'm gonna show you later on. We'll see.
So
We'll
why can't we print option I32 now? Because the format has not been implemented.
Yeah, what it told you. As I said, it's explicit right now. Since it became option I32, you need to tell the compiler what happens when it's none. When the value is not there. So in terms of an iterator, when it ends, well, we do need a limit first because this counting iterator is limited. Let's give it a limit.
Yeah.
Add a new field called a limit or whatever.
And let's say this is a I32 as well.
Yeah, fine.
Yeah.
Now, when the number is over the limit, you're gonna end the iterator by returning none.
Okay.
Otherwise, return the number. So basically, you return none to signal the end of the iterator.
If number.
This is, by the way, not like a beginner problem. Like you wouldn't expect this to be in a beginner tutorial. But I like to start with things how they're made, like the essence of it, so you could actually get a feel of how they work, really.
Yeah, I see. So it says cannot find value number in this. Wait, what?
Because number, is it a local variable or a field?
It's a field.
In self, so?
Yeah.
So you need to do self dot.
In self, I see, self dot, And, and then self dot limit. Okay, and now I can just, well, in this case, what I can do, and I can just return, but now then
none.
it would. Yeah, but what I'm thinking is that if I just do if, that means that they can call the next again, and it will increase the number. But if I put the if statement before that,
yeah, exactly, fine.
it will first check, then increase the number.
Yeah,
So we will
true.
never
That's
go
good.
past the limit. Yeah, okay. So that would be none.
It doesn't matter in functioning in the short term, but it does matter in the long term
Yeah,
because what is going to happen, it could overflow for no reason.
yeah. So that would be none.
Remove the semicolon.
What? Ah,
Then do
semicolon.
else after the if. Just like C++.
Oops.
Inline, you can put else inline. Inline with the closing.
Yeah.
No, keep that. Keep that.
Okay.
Control Z. Just remove the new line from the beginning of the else. From the beginning of the else.
This line.
No, here. Okay, fine. There you go. Remove the long line. There you go.
Yes. I see. Okay.
Okay.
And then.
So now what you need to do? Just
put
get
these
that.
two inside there.
Exactly. There you
go. Well, we don't really
Control
need the else
S.
because.
True.
Because.
True.
If it goes in here, it will always return.
Yeah. But I don't know if it would work with
returns.
Good.
Interesting.
So we can remove it, right?
Yeah.
That's why I love auto formats. Like this one would fix it automatically for me.
Yeah.
But the problem with this is that you don't, the compiler doesn't like it because you cannot see the type, you know.
I see.
But with this, you can see the type of the two branches, so we can figure it out, you know.
I see.
Without the return. I mean, you can get around that using a return, but there's no need. Just do it like this explicitly. It's also much more readable, I guess.
Yeah, I guess it's
so try it now, but hold on, there's some errors.
Yeah, it says missing structure fields limit. Oh, okay. So I have to give it a limit as well. So the limit, let's say it's 505 for some reason. And it's not C++, I see.
Exactly.
I have to say limit, go on, 505. Now it says option identity doesn't implement FMT display. And when it's none, it needs to take care of it.
Yeah.
But it needs to take care of it when?
So you need to break the loop when you get none.
Yes.
Yep.
Well, I'm guessing if we wouldn't be using loop then.
You can use loop, just use loop and just break if this loop break.
Oh, okay. So
I mean, there's a lot of ways to go about this, but I'm going to show you later on. Anyways.
Single value equal.
Just try right now what you know.
Can I do this? Does this work?
No, that's not possible in Rust.
Okay. I see.
There's a better way of doing this whole thing, but we'll see about that later. Okay.
If equal non-break, and then let's say else.
Why it's
interesting?
Because here this is still an option, so you have to unwrap it in single value. Although you have checked in this case, it's still an option. Not there.
Oh, not
because there it could be none. When it's going to be none, you're going to crash instead of breaking from the loop. But you need to do it when you know exactly there is something inside the loop. No, the single value itself.
Oh, the single value
in here. No, here. Exactly here. When you know that it's not none.
I see.
This branch, you're sure that it's not gonna be none.
Yes.
So inwrap. Inwrap.
Okay.
But you can already see something wrong, right?
Yeah, I can't do that. Oh, okay. I can do this instead. Just control.
Exactly. So when the expression becomes, you know, more complicated, you have to do it this way then. Okay, there you go. Now try this out. There is a better way. There is a better way.
Yeah, there is a better way. I see. There we go. It's foreshadowing.
Make limit a bit smaller.
Yeah, yeah.
So we can easily verify that, I guess.
45. There we
go. Okay.
There,
there you go. So you have made your own iterator right now.
That's cool.
Okay, so there's a lot of things to make this better.
Yeah, I suppose so.
Yeah, because I didn't teach you how to do that. So, but now it is the opportunity to do so. So first, pattern matching in Rust is the best. And Barry Seuss, welcome to the live stream. Ramadan Kareem to you too. Thanks. All right, so there is something called match. Okay, there's no switch. Switch sucks. We have match. Okay, match single value, and then sum. So if it's sum value, we're gonna print that value. Otherwise, if none, we're gonna break.
So essentially, switch statement without the word switch.
Exactly. But it's much more complicated. Not complicated, but like the more advanced. You're gonna see later on.
I see.
I cannot find. I just need the opportunity to show you that later on. Anyways. So try now, Kargaran.
Match. Okay.
So this is the exact same thing as you had, but much sweeter.
But much cleaner and better looking.
But you can actually do this better, but try to understand what I'm doing here.
Yeah, so you're matching, counting iterator next, and then you saying if there is some value inside it, print it. Otherwise, if it's none, break out of the match and the loop.
Yeah, so what you understood.
Okay. Well, it essentially does the same thing as the if.
Yeah, exactly. But like, how does it work exactly here? So let me try to explain. So here, of course, we're turning an option, and here basically if it's sum, then it's gonna give us back the value inside that sum. It's gonna unwrap it automatically, right? And then we're using that value. If none, we're just gonna break. We don't have any value to capture, you know. Here we're capturing the value if it's sum.
I see.
Now we could make this.
Don't wrap anymore.
Yeah, exactly. Yeah. So because the compiler is sure that you're not gonna, you know, F up here.
Yeah, I see.
So there's a better way to do this syntactically. Sugar.
Okay.
So while let sum value is equal to this. Print line value.
Yeah.
There you go.
Oh, okay. Otherwise, just it will come out of it.
Same thing.
Yeah. Yeah. But like this doesn't check for essentially if it is none.
It does check for it.
Check for.
You see this?
It does check for it, but like, yeah.
Yeah. But it doesn't give you the opportunity to handle the none case yourself.
Exactly. That's
the none case is just nothing.
If we want
it just breaks.
Yeah.
It just breaks out of the loop, which is exactly what we wanted. So there you go.
Yeah. In this scenario, that's what we want. But like, for example, I'm thinking in a like environment where
of course.
you don't want
null if you want to handle the none somehow differently, pretty much.
Yeah, I see. Okay.
Okay, so nice. Now let's actually move on to the next level of beautiful. Let's implement iterator now. Let's actually do it the way the standard library does it, instead of just because it's the same semantics, yes, but it's not gonna work well with the other iterators that other people make and the standard library make.
I see.
So now I'm gonna introduce you to traits. Now you see,
Okay.
in Rust, we don't have inheritance.
Okay.
We only have interfaces. They're called traits. Though more
Okay.
advanced than more advanced than interfaces. But yeah,
Okay.
you can think about a trait in Rust as like an interface. So in the standard
Okay.
library, you have a trait called iterator. So you're gonna implement the iterator trait, the iterator interface for who? Who's
For std?
for counting iter,
Oh.
right?
Ah. I see. Oh yeah, for counting. Yeah.
So I'm gonna try to give you the chance for the compiler to give you the errors and see where it takes you. Cargo R and see what happens.
Let's see.
I'm curious how the compiler would help a beginner.
Yeah, it says not all trait items implemented, missing item and next. It says missing item and next in implementation.
What it tells you in
Okay,
help.
so essentially it's telling me that the iterator like interface, I'm guessing,
Exactly.
is missing two functions. Well, one function. One function is next, and one item
Is item.
that
Yeah.
would be, yeah, the item would be
So
essentially
what
the
it
number.
tells you in the help. There is some two help labels
In the
there.
help, yeah, it says implement the missing item.
Yeah.
Type item equal type. Like literally is telling me what to type.
Try it.
Yeah, okay, let's see. Type item equal. And what is this monstrosity?
This is a comment.
Oh, that's a comment.
Multi-line
Let's see,
comment.
okay. So can I here just say, since it's
What is the item type, the element type of the iterator?
well, it would be I32.
Exactly. There you go.
That would be the what?
Okay.
This is confusing. Like, okay, so I'm essentially like saying that there will be an item, and this item is of type I32.
That's the iterator item type. Yeah.
Yes.
There
Okay.
you go. You're just declaring what the iterator. Yeah. Okay. What's next?
And then the next, I need a next function, and I'm guessing this.
Okay.
Next
So
function,
see the signature of that it's telling you in the help. What is it?
Yeah. Oh, it's saying to get a next. Oh, wait. First of all, it's not the correct. And
Just see
then
the whole
I have
signature,
to pass into the next.
And what it returns?
And it will return an option, self as iterator item. Ooh, okay.
All right.
So return an option. Option self as iterator item. Okay. So let's try.
So next, what it takes first, yeah. Beautiful.
Yeah. Let's say not self, and then return would be option. Yep. Option. And self as right there. An item. And that should be it, I guess.
Close the other one, yeah.
And that's it.
You're missing one bracket, what is it called? Angular bracket, I guess? You're missing one closing one, I guess? No? Oh, no, you're not. Okay, it's fine, fine.
Yeah.
Never mind. Okay, so what's the implementation of this? You already made it.
Yeah, I already have it here. Like, can I just copy this?
Exactly.
Yeah, let's see.
And remove that impl now. No need for it. The impl block that they made before, remove it.
Oh, yeah.
Yeah, exactly. We don't need it anymore.
Yeah. Okay, so let's see what happened here. So
try to run
we have
this.
an item. Okay, let's see.
It works the
it
exact
ran.
same way.
Nice. Yeah, nice.
But right now you actually have a real iterator.
Okay, I see. So this is like literally the iterator implementation that Rust
Yeah,
has.
now try that
We
take and
just
filter
overrid them.
over it. Let's try that filter. Copy that filter number, even, and so on. That you see there, that is in the comment.
Oh yeah, this one.
Copy
Yeah.
the filter, just the filter part of it, and
Just the filter. Yeah.
and paste it after the counting iterator, where you actually
Okay,
create the
bring it to
iterator.
next.
No, after you create the iterator. Try
Here.
that out. Dot. Okay.
Hey, wait.
Try this
I
out.
can do that? Oh, I can do that. Okay. Interesting.
Try this out.
Yeah.
There
nice.
you go. You actually have created your own iterator as a beginner.
Oh,
That's a
that is
crazy
pretty cool, to be
achievement.
honest. Yeah, that is pretty cool. But what I don't understand here is, what is the point of item? What is
Yeah,
item
I
doing
knew
here?
you were not gonna have that question, and I actually didn't get the answer anywhere until I figured it out on my own. But
Ah,
that's
you
gonna
did,
come
okay.
in acts like it's gonna come in handy when you go into generics, and you need to
Hey.
access the type. Actually, you have something similar in C++ when you're working with generics. In C++, you do something like this, using item is equal to, well, in this case,
Yeah.
32t. That's something similar there.
Yeah.
Notice here, actually, what you're saying here, self as iterator, though you don't need as iterator, it's just the compiler being pedantic. You could, like the compiler would figure it out, just say self item. You're basically referring to this item. Now the contract of this iterator is that you need to have some item type, some type that is called item, the type of the elements being iterated over. Oh crap, you're probably not seeing my... can you follow me?
I can.
Just right click on
I'm
me and the focus participant. Or you could watch, you could watch the live stream too, fine.
Yeah.
So advance the iterator and returns the next value. Returns none when iteration is finished. Individual iterator implementation may choose to resume iteration and so calling next again may or may not eventually start returning some item again at some point. So that's basically undefined behavior. Anyways, call to next returns the next value. Alright, so what we have here, we have a next function. What that next function returns? Option of self item. So it is important what you define here as the item type. It would be reflected on the next function. Self item.
I see.
So the item of self, right? And now this is, I mean, you can go ahead instead of self item, you could just go directly and plug in iterators. But then if you change this to something else, I64, now you gotta change it everywhere where you use that.
I see, okay.
So that's the first advantage. You don't have to copy it around every time you change it, right? So you change it once and you forget about it. That's the first advantage. Second advantage is, I don't think I can explain it right now, is when you're basically using generic code. You may want, like, let's say you have a generic iterator and you want to get the type of that generic iterator. You can just say that iterator, whatever that is, that generic iterator, t item, and then you get the type of that item. Just like in C++, but generics in C++ are also crazier. So anyways, there you go. That's it pretty much for the iterators.
That's cool. I really enjoyed this, like, also I like the fact that, like, it's kind of simple to
exactly.
overwrite it.
Like, I mean, creation, I still couldn't I can understand the mechanism of C++ iterators and ranges, but I still couldn't figure out how to make one myself. It's wild. And first of all, second of all, the errors are crazy. Template errors. You just get a wall of error, you just gotta figure out yourself instead of trying to figure out the error itself, what it is. It's just better to figure it out. Anyways, so
this is actually kind of insane. Yeah.
Yeah. So
I really enjoyed this compiler.
So instead of doing this, you could also make an impl block and make a new function. That's idiomatic. I mean, this is fine, actually. This is fine. It's just that idiomatic too. If you want to, you can impl counting iter, just like before, you know, the impl block we did before. New, you know, kind of like the constructor in Rust, in C++.
C++, yeah.
Fnu self. And notice here that instead of saying counting iter, item, which is fine.
Yeah.
But again, if you change the name here, you have to change it everywhere again.
I see. You have to change it everywhere.
So better just make it
Self
generic
make
self.
it easier. Yeah.
And same thing here. I could actually say counter iter and construct the thing. So I could say number i32 limit i32 and then number and limit, but I can do this nicer a bit, and the compiler would actually tell me shorthand struct initialization, because if I do control dot, I could just do it like this. You know why? Because they have the same name.
What? I see. That's cool.
Though one thing to keep in mind with this feature is that, let's say you have some option here instead of i32 for whatever reason, like you have something more complex, and you may fall into this trap of just saying in wrap, but it's not going to work at that point. So in this point, you gotta have to go back to the original, because it has to be the same type and the same. So this is just a trap that you can fall on.
Yeah.
There you go. So instead of counting iter here too, you could just say self.
You can just say self.
Nice. There you go. Now
so
instead of saying this,
constructor,
okay, counter 3245. Okay. There you go.
It will give the exact same result.
Yeah, exact same result, just more idiomatic.
Yeah.
There you go.
Nice. Okay, that's pretty cool. Constructor.
Now let me show you some enums.
Oh,
enums are interesting.
The one that you said is crazy.
Yeah. Let's say you want to create some i32 option. We're not going to use the generic. Generics are quite complicated in Rust, though I can explain it later on. Anyways, so let's instead of using the standard library option, let's make it ourselves. Why not?
Okay.
It's pretty simple actually using enums. So in C++, how we would do this, you would actually say enum, let's say option kind, right? You're gonna say either some or none, and then you're gonna have a struct option where you're gonna have a kind. Oh crap! Option kind. Okay. Option kind, and you're gonna have what is it called? Oh yeah, the value, I guess. Actually, oh yeah, the value. Let's say i32 for now. Crap. Value.
Yeah.
Well, it's gonna be in32t.
Yeah.
So you can have something similar to this. So like enum is just a label, like a tag. Is it some or none? And then you're gonna have the value, though you could well, I guess you could use a union, but no, you don't need that. But you're gonna need a union if you're using the results and so on. But yeah, you see that it's kind of weird.
Yeah.
But maybe you're used to it, then you wouldn't see the problem with that. So here in Rust, this is how you do the same exact thing. There you go, done.
Oh wow. Okay.
So this is called a tagged enum, or like you have the actual type, but each type could come with its own data.
I see. Okay.
This is exactly like what we had before, pretty much. Though right here the compiler can do an optimization, where actually can it? No, not in this case. But there is a type called non-zero, right?
Okay.
And the e32. And now here you can actually do that optimization which is that it's kind of it's like option is like have no cost at runtime. So why? Because it's kind of like just gonna be like compiled like a pointer to some degree because of this. So sum, it could be, let's say, non-zero, so it can't be 0. And so the compiler is smart enough to know that since it cannot be 0 here, we can actually reserve that 0 for none instead of allocating the tag in its own memory. And so the enum size would be just U32 to, yeah, kind of, I guess. Yeah, pretty much. So it is very smart in that.
Interesting.
You don't have to worry about this as a beginner, so there you go. Sine V32. And now you could say, I don't know, x is equal to option I32 sum. Let y option I32 none. This is exactly how the standard library option works, but with generics.
Yeah, I see.
Though we can do some generics, some simple generics though. We're not gonna go in detail. You can do some t value here, and there you go, done. I guess.
That's the entirety of the.
But here we have to call it something else.
Yeah, because.
Yeah, my option. Same thing again, but now I could use any type in existence. There you go. That's how you do it.
That's cool. Nice.
My option.
Yeah, much easier than how C++ would go about doing that.
So you can go crazy. You can go out, like, let's say either this or that.
Yeah.
I don't know. Let's say this or that. Let's say they are the same type. Oops.
Yeah.
This or that. Let's say you want this or that to be the different types. Then you can do this. And then like you can match on that either. Oopsies. Whatever value, and then we can match on x, right? And if it's this, then we're gonna get the first type, right? And then we can do whatever we want with that type. Or that, y, and then do whatever you want with that type. You see how it goes?
I see. Well, can you hear, like, let's say here, for example, for x, you're printing that. Can I just say x dot type? Can I get the type?
I don't think so. And if there is a way in C++, but there is an overhead associated with it. Though you can make a function that is generic and do something depending on the type of that generic. But you do have you need access to the generic. But like to get a value at runtime and get the type of it, I don't think you can do that directly. Unless, again, as I said, you make a generic function and do what you want with. But depends on the use case. But if you're talking about reflection, you can actually do that using macros. And in Rust, macros aren't glorious text processors like C and C++. They're actually taking token stream from the compiler, actual AST, you know. And well, not AST. Is it an AST? I guess so, yeah. And then you give back token stream.
Okay.
Like, actually, you take a token stream, then you can turn it into an AST if you want. Or you could just work on the token stream directly, and then you can turn it back into a token stream, like create whichever token stream you want to replace it with those tokens. And you give it back to the compiler. So you get better iterers, more hygienic macros, more powerful macros, with type checking and everything. So no surprises there. Though it's a bit complicated to work with. But But like generics is a whole different story. I love those too, but I don't think we have time to actually cover those. They need a separate video. They need a separate line.
They are complicated, to be honest.
Yeah. Now, if you're still not tired, I could show you a
No, you
bit
can
of
go.
taste of ownership in Rust.
Okay.
Though, let's take a 5-minute break, I guess, and then we come back.
Sure.
All right, so I'm just gonna mute the mic. Okay, back.
Okay.
Mic is on. Great. Let's go. So,
Can you hear me?
yeah, I can. Let's go.
Yep.
All right. All right. Great. Like, iterators is something that beginners don't even think about. Creating your own iterator. So,
Yeah.
let's go. All right. So, yeah, I wanted to show you a little bit of ownership because Rust ownership have like, it's kind of a very steep learning curve because it's like on safety. So you gotta basically, what should I say? Kind of like prove to the compiler that what you're doing is sane and safe, that you know what you're talking about.
Yeah.
In terms of ownership of memory, etc., etc.
Yeah.
So, yeah, I'd like to teach you some of it, I guess, to give you at least a glimpse of it.
Thank you.
All right. I don't think we need these anymore for now. I think it's fine for now. Let's clean up a bit. Okay, great. All right. Let's see what we got. Okay, so can you make a struct called friend?
Okay. Struct called friend.
Yeah.
But what was the? I don't remember the.
Yeah, just go with it. The compiler will help you.
Yeah. The naming convention.
Yeah, just go with it.
Yeah.
You'll get a warning if
And
it's wrong. Okay.
oh, it's not wrong.
Okay,
Nice.
so name. So it will have a
Name.
And I actually didn't show you the difference between stir reference and string. So to keep it simple for now, go with string with S. No, not that one. I'm going to show you that one later on because that's a little bit more complicated, but this one is fine. Basically, the difference between them is that stir reference is just a reference to a string, kind of like a pointer to a string.
Yeah.
But string like that is actually allocated, like a CD string. The allocated version is easier to...
And char star.
Yeah, is the string... This one is easier to work with because it just allocates. You don't have to work with... to mess up with the lifetimes of the reference, which you actually got to prove that it's saying to the borrow checker. Well, let's go step by step, I guess. Okay, so name string, and you're gonna have a friends field because every friend have their own friends too. So friends.
Friend. Oh wait. Friend. And that would be of type friend.
Vec friend.
Oh yeah, vec.
Because you can have multiple friends, you know.
Yeah. Vec. Friend.
Exactly.
Friend.
Let's go. And the comma. Yeah, there you go. So name and friend. Yeah, that should be fine for now.
Okay.
Great. Nice. So make some couple of friends in the main function.
Of a friend. I wish it was that easy.
I mean, I didn't tell you to go ahead and find friends. Just make friends, imaginary friends, you know.
Just make friends. Easy.
Easy.
What are you even talking about? Oh dear. So friend. Wait. No. This. Wait. What? Look at how to read.
Yeah, just like do it like a kid. Just try whatever and let the compiler help you.
Let the compiler help you. Okay. So that would be name. Let's say name on Alex. That would be a string. Alex. Oops. Oh, no, it's correct then. Okay. So vector friends. Ooh.
So friends.
Can I do this?
No, it's not an option.
Can I do that?
First of all, say friends.
Okay, friends.
Okay. Now create a vector. You can use the macro. You can use a macro that I didn't teach you about yet to basically initialize the vector in place.
This one?
Exactly. Yeah. There you go.
Yeah.
So the autocomplete told you, right?
Yeah, it did.
Great. Let's go.
So, what is the colon?
Okay, so inside just keep it as empty for now because you don't have any friends for Alex yet.
Okay.
So create some other friends
Alex
now. Alex is lonely.
Alex is lonely.
Okay.
Like all of us.
True.
on a Saturday night coding.
Okay, let's go.
Let's say
just copy paste and change the name.
Ali.
It's that simple.
Ali. Oh, yeah, let's just copy and paste this rest. Over. It's fine.
Just create another friend again.
A
third friend.
Okay.
To complete the team.
Let's say I don't know. Leave it.
The naming convention. And you
Yeah.
have forgot to change the names even in Ali? Or
I think, yeah, it's correct.
yeah, that's good. That's good. Never mind.
Yeah.
Like basically Alex and Ali shared the same, you know, the first two
Yeah,
letters, so I thought it was
I
you
see.
forgot to change. Anyways,
Yeah.
so
Okay,
now
so
compile this
this
and
is
see the
wrong.
first, yeah. Compile it and see what's
Yeah.
wrong. I mean, it is expected to make this. So what
Yeah.
it told you?
So it says, Ali, try using a conversion .toString. Ah, okay. Well,
But why? Expected what?
something. Oh, it expected a string reference. Oh, expected a string, but got a string reference.
Yeah.
Which I'm guessing this is a string literal. Like
Exactly.
essentially equivalent
Exactly.
of C++. And we need to give
We need to
it like
allocate it,
some sort of like
right?
std
Yeah,
string
I
or
mean,
something.
it told you what to do. It's better. I mean, you
Oh,
could
it
do
did?
it that way,
Okay.
but it's better what it told you to do instead.
So let's say Alex, then dot to string.
Yeah, exactly.
To string. Oh, okay.
There you go. Now do the same with the others. Though in Rust, since you have a powerful in type inference engine, you could just say .into and it figure out the conversion if it is possible.
Ah,
So just say
interesting. Okay.
.into instead of toString.
Ah, okay. Cool.
Just copy to into to all of them. It's gonna be
Yeah.
the same, but you're gonna rely on the
Yeah.
type system instead to infer.
Oh, so the type system, does that infer the type at compile time or at
Of course, at
runtime?
compile time.
Okay,
Like
at compile time.
it's just
Yeah,
like
yeah.
C++. You don't pay for
Yeah,
what you
yeah.
don't use.
Yeah.
So
Okay. Cool.
okay, we can make an
So
impl block and make a new function
okay.
to make this a little bit nicer.
Simple. And call this, what function would it be?
No,
Oh,
impl
for
for
the
what?
friend.
Yeah, exactly.
And then
Fn
function
new
make friend.
new.
Oh, new. Okay. New. No, not that. New.
You thought about make pair, std make pair in C++?
Yeah.
Gotcha.
Oh.
Okay.
Yeah.
So new. How do you make a friend?
How
Good
do you
question.
make a friend? True. Good question. I couldn't figure it out 4 years at university.
Yeah, enter
so
the
I'm
argument's
guessing.
name.
Yeah. Yeah,
Name.
I'm guessing if you want, you need to pass in a friend into new as well, right?
No, we're just gonna initialize it using name and friends. We're just gonna start with vec empty for now. So new is
Okay.
gets a string argument.
String argument. Okay, so that would be name. Wait. Completely forgot how we did this.
It's just like what you do with the fields. Just copy the field. It's consistent.
Like right here.
No,
Similar
here
to
in the
this.
declaration, because this
Right
is a
there.
declaration.
Okay. Yeah.
Yep.
So essentially, here we will say name, then
Exactly.
string.
There you go.
And
no need.
we need to pass in a friend. Okay.
So now just return friend or return self. Well, first of all, declare it here.
Oh yeah. Here there would be return self.
With exactly. Okay, so now return self. Return self and then initialize it.
Then return.
Well, without return, we don't need return since it's the end.
Without return. Yeah.
Since it's the last statement in the block.
Yeah. Expected value found module self.
Not self with this little s.
Ah.
Exactly.
Self.
The type, right?
Yeah.
So initialize that. Just like
So
what
if we
you've
can
done
only-
here. You just copy this.
Yeah. Oh, okay.
Exactly.
And then this would be
Name directly.
instead of yeah.
And since it's the same name,
Yeah,
what you're gonna do?
type, yeah.
No pun intended.
Name.
Same name, yeah. So
Oh,
what you
okay,
can
yeah,
do?
I can just
Exactly. There you
do
go.
that.
And friends, you could
Okay.
just keep as vector empty as default. So
Yeah,
now,
I see.
just change that here, and there, and there.
This one?
Just say friend
So that
new,
would be-
you know. A new is basically a static function here, because it doesn't take self. It actually constructs self.
Yeah.
So friend, namespace. It's
new.
namespace, because it's a
Oh,
static function, yeah.
New.
And then you give
And
it
then
the
the
name.
name would be Alex.
Now here you could
Dot
just,
into.
instead of saying into like that, which sucks, you could just here pass in stir. What is complicated is actually storing that reference, because you're gonna add lifetimes and such, which is an advanced topic for now. But here, if you just pass it as an argument, it doesn't matter. It's fine. It's gonna be fine.
Okay.
So you could say stir here and say into here.
Okay, so here I can just say stir.
Reference, yeah. Stir reference. We cannot say stir by itself because it doesn't have a size. So, okay.
And for name, it says expected string found.
So the into, yeah, the into. But yeah, remember that what I've told you before about what happens when you... No, I mean, yeah, just do what you thought it would do, yeah? Just do what you're doing, right? Yeah, now what's the problem?
Oh yeah, I remember.
That trap that I told you, yeah, exactly. There you go.
There we go. Okay.
Exactly.
So we are passing in a string literal here and then changing it to...
So right now we're avoiding, we're currently avoiding storing a reference in a struct because you're going to add lifetimes and such, which is complicated for now. But if you just like, you know, give it as an argument, the lifetime is pretty well defined most of the time. So it's fine in this case. So, okay, now you could actually do this better by telling the compiler. So how we can tell the compiler to accept any string, any type, either a stir like this or string like this, doesn't matter.
How we just say
if, because if this was a toString, if it was an actual string, it's not gonna accept it.
Yeah.
So we can tell the compiler to accept both by. I don't think I told you this before, so.
Can I just do this?
I wish it was that easy. But I don't know why they didn't make it that easy, to be honest. Anyways, so to tell the compiler to figure it out, we can say impl into string.
Oh, okay.
So you see when you did into here, this calls into a interface, into a trait called into.
Yeah.
So like when you want to define some conversion from one type to another, you can actually impl into, like let's say i32 for friend, you know, or whichever. You got the point, right? And then you have to do the stuff that needed for that. Here what we're saying is that we're telling the compiler to accept anything that implements into string, meaning that it is convertible to a string.
I see. Well, wouldn't that kind of let me just abuse it and just put something like 20?
I mean, yeah, it can be converted to a string.
And then it would turn the 20 into a string.
Yeah, it can be converted to a string, right?
Something like this.
Yeah, so it depends on how you want it to be. There is another way to actually not allow that, but still allow string and stir. Let's not go that way, I guess, for now. It's a little bit advanced. I'm not sure if there's not. Okay. So yeah, the other one, I think you're gonna need to use another trait. Don't even remember what the trait is called. But anyways, I think as ref. Oh yeah, I guess so. Don't actually remember. Maybe as ref. Used to do cheap reference too. But honestly, let's not go the advanced path right now. Let's just stay in the tracks. The trait bound string. Find
Let's
implements.
just do this first. Alex, there we go.
Okay,
Let's
so
give
now we
these
could just
people
do the
some
same.
friends.
Yeah, we're gonna do that in a second. Just convert those two.
Oh yeah. Okay. Let's take this and just do that. That. Oh, what the hell am I doing? I'll just copy this instead of. And then call this one Ellie. This one. David.
I mean, I wanted to show you something
Yeah.
else how to do, but while we're at it, let's tell you, let's tell you how to show you how to make a conversion, how to implement the into trait. I don't know if it's
Okay.
that easy though, but let's see. So impl into. So basically what we want, instead of saying friend.new, we want to be able, let's say, to say Alex into, and then it would convert you into a friend. But though you need some way to make it out a friend, right? So you gotta tell the compiler that you want a friend, right?
Yeah.
Tell the compiler that you want a friend.
The compiler is gonna be like, get the hell out of here, what are you talking about?
Okay, so impl into.
Yeah.
Actually, not into, from. We want to implement from. From is kind of like the counterpart of into. So if you implement from, you automatically get into. If you implement into, you automatically get from. And this is actually you can do it using some blanket implementations, which we're not gonna go into right now. But either way, implement from string.
From string.
Yes. From it's a template. From and the template string. Well, it's actually generic, but you got the point. From string. Or actually stir, but yeah, it's fine. Impl for who? Impl from string for who?
Oh yeah. It would be friend.
Yeah.
Yeah. So
for first.
Okay.
For friend, yeah. Now you see, let me show you some interesting way of doing this. Control dot.
Yeah.
Control dot on here, on the error here.
Okay.
Implement missing.
Oh, implement missing members.
Yep. Do that.
Okay. It says the host doesn't allow running this command. If needed, ask them to enable it.
How to do it? Ask them.
I don't know how to ask them.
Good question. I don't know how to do that. So let me just do it myself. Okay. But it should be. There you go.
Oh, okay.
So this is the result that we get. So the traits have a from function. This is an interface, right? From, you get the value that you want to convert from, and then you have to give a self. So how to create a friend from a string?
How to create a string from a string?
No, how to create a friend from a string.
How to create a friend from a string.
Yeah,
so if you just call
friend new.
Friend new, yeah. And you, and then you just pass in
the name
value.
Call this name, I guess.
Maybe. Oh yeah. Name. And that would be value?
No, just pass in the value. It's not a declaration. You don't.
Oh yeah.
There
we go.
Like basically rename these as name. You can refactor it. Like rename symbol F2.
Easier. I mean, it's easier to just do that.
You could just say F2.
Yeah.
And yeah, there you go. There you go. That's it.
Yeah.
Alrighty. Or you can, instead of friend, you could say self, right?
Yeah, because it's of type for friends.
So now, if we increment this out, that you have to tell the compiler that this should be a friend. Well, we already did that actually. Hold on, what? Oh yeah, because this is a stir, not string. Can we actually do this? I don't think we can. No, of course not. Of course.
No.
Can we do this?
Yeah, it seems like it's not
There we go. Okay,
complaining
cool.
anymore.
I just was worried to need to
So
explain
would
to
that
you
be
lifetimes right now, but no, apparently.
would that be into or would that be from now?
I mean,
It
you
would be
can
from,
actually say from, but if you implement from,
yeah.
you don't need into. It's gonna implement into
Okay.
automatically. It's using a blanket implementation.
I see. Okay.
So I think how it's do it, I guess, is impl into friend for. I don't even remember how to do this. I think it's gonna be generic. Yeah, impl t for t where t should. Yeah, it's gonna get complicated real quick. Let's not go that way for now.
Yeah.
So there you go. It actually works. Now you could actually take a, and like the normal way that you would do this, of course, is actually. Well, I mean, can you actually do that? Stir from. Interesting. I'm not sure how to do this. But let's say this is a string, okay? Then you can, of course, do string from. What? Hold on, what I'm doing? My bad. Oh crap! No. Go back. Go back. We're gonna say friend from. Yeah. Friend from. What is it? Alex. Okay. There you go. Friend from Alex.
Okay, I
right?
see.
So this is what you're actually implementing, but you get this for free, since you have implemented from. So there you go.
But then if I am doing, let's say, I'm just gonna kind of undo a little bit. So if I'm doing that, do I need to tell the compiler what type it is? Because it's
No,
going
you don't.
to infer
You don't
type
actually.
from.
In this case, you don't. Yeah.
I see.
Yeah.
Okay.
There is another way to, by the way, give it the type, which I prefer. Sometimes though it gets icky, as you've seen before. But basically, instead of declaring the type to the compiler like this, what you do is you can use the turbo fish syntax, like this. What the heck? I don't know how to pass in the into thing. What the heck? I guess maybe it doesn't work for this one, because it's not a generic somehow. Anyways, never mind.
Yeah.
Okay, there you go. So now I could do the same thing with the other ones. That you got the point. So like Ali into David into.
Yeah, you have to give them the type as well. Yeah. Okay. And
but yeah, as you've managed to see yourself, is that if we use from instead, we don't even have to do the type, because we already did it. So there you go. So
okay, cool.
All right. So now you have actually learned a bit about traits, a bit. So that's great. So now, to the actual thing that I wanted to teach you in the first place, which is a bit about ownership. So let's give these guys some friends. Fn new. Say fn. Yeah, do it yourself. Fn add. Add friend.
Add
friend.
See
the warning?
Is it gonna scream at me that you haven't done the correct naming scheme?
Exactly.
So I am guessing I am passing in a friend into here. So it would be.
But first of all, what you need the self.
Oh yeah. So I need to pass in self.
Well, self with a S, with a little s.
Yeah. It's little small, like big S is kind of confusing, to be honest.
Because big S is basically the type that
Yeah.
you're getting, and little s is for the actual instance, like this.
And show, yeah,
You know,
object, I see.
in Rust and in C++, we
Yeah,
say
yeah.
this. But if you notice
Yeah,
something
okay.
though in Rust, is the fact that you, like in C++, you're actually, when you're initializing something, you keep on partially initializing it. Like you say this, field 1 equal to this, right?
Yeah.
And then field 2. So while you are in that process, you have initialized fields. But in Rust, we don't do that. We actually initialize the whole thing at once.
Okay.
Yeah, okay. So self and the other friend that we're going to add.
And that would be...
First of all, you need to give it the name. And instead of friend, you can say self. So yeah, say some friend, name it friend. With a little f. The type is going to be self.
Oh, the type is going to be self.
Because self
the type
is
going to be friend. I see. Okay.
Yeah.
The type is going to be self. Okay. Then returns self, I'm guessing as well.
Well, no. There's no need for this, right? This is just like a function that would have some side effects. Oh, this is just add,
it doesn't return anything. Yeah. I see.
And this can be like this. And there you go. Okay. Alright, so try now to add a friend. Self.friends.
Friend.friends.
Self.friends. Self first, because it's a field of self. Exactly. Dot.
Self.friends. Dot. Is it add or... Let me see. Append.
It's push. It's push.
Oh, push. Okay. Push, and then that would be...
The friend, yeah.
Friend.
We're gonna have some problems, but I want to see you. You need to see the problem first.
Cannot mutate. It says cannot mutate immutable variable self. So I'm guessing I'll just make this mute reference.
Yeah, try.
Mute reference. Yeah.
Great. Okay, now let's try to add some friends. Now where the magic happens. Because adding friends isn't that hard, even in Rust, so.
Add friend. And let's say W gets Ali as a friend.
Okay, so what's the problem?
Yeah, well, this is not mutable.
Great.
Yeah,
next.
That should be...
Make some two people share one friend later.
Okay,
in
share one
whatever.
friend.
Yeah.
Ooh. Let's make Ali mutable as well. Let's say Ali, let's add friend, it would be Alex.
Okay. Okay, now the borrow checker. Your first encounter with the borrow checker. Adding friends is not easy.
Wait, let me try to see if I can figure it out myself. So
yeah, get help with the compiler. Get help with the compiler.
Oh yeah. That's right. Yeah, so it says oh my god, there's so many things.
Yeah, don't get
mismatch type. Expected, not doesn't matter. Okay, there we go. Borrow of moved value Ali. It says let Ali move occurs because Ali has type friend, which does not implement copy trait. Interesting. Okay. Ali.add friend borrowed here after move. So in this method, this parameter takes ownership of the value. Okay, so that makes sense. That literally makes sense. However, interesting.
Actually, this is not just the borrow checker. The solution would be harder than just checking out with the borrow checker, actually.
Yeah, I know that the solution.
But yeah, just tell me what's your thoughts right now, pretty much.
Yeah. My thoughts would be the fact that because
what you understood,
Ali, holds Ali as a friend,
Yeah.
that means that David as a self now controls Ali as an object. And then when Ali wants to add Alex as a
So yeah.
friend,
Hmm.
because David owns Ali, Ali cannot have Alex as a friend anymore.
So yeah, basically, David likes to own what he like his friends. So he cannot share his friends with other friends, with other people. So he
How
just
weird.
owns Ali. So yeah, you cannot take it anymore. So you cannot borrow him, you know. You cannot, like,
You
he
cannot
already
have a
take
friend
it.
anymore
He already
already.
taken it, bro. You
Honestly,
cannot borrow him
it's a
here.
monogamous relationship.
Yeah, because add friend takes a reference. It borrows Ali.
I see.
But Ali is already taken, so what you gonna borrow?
But here's a question. Can I do something else then instead? Can I instead
You can
of
actually.
self,
Mhm.
can I instead of self as a friend, instead of passing a reference, pass a copy of Ali?
Well, the thing is, you can just
It
you
wouldn't be.
borrow. Like instead add friend, you don't need to own the friend. You can just borrow him.
Ah, okay.
And how do you borrow?
Reference?
Exactly.
Ah.
But though
So
it's
just
harder than this because this is a graph data structure. So we're gonna need another solution, but this is a good start if it was that simple. Of course.
Yeah.
But yeah, there you go. Go with the reference now.
Interesting. So if I put the reference here.
Not there in the type.
Oh,
Before
not
the
there.
type.
In the type, yeah. Okay, so it says mismatch type detected friend found reference as friend. Okay, let's dereference this.
Well, you cannot do that.
Not mode. Oh.
So remove the dereference. Now, what's the problem is that here we're having a friend, a reference. We're just borrowing the friend, but the vector is selfish. It wants to own the friend.
Mm-hmm.
So we can add a reference, but then you're gonna meet the monster of lifetimes in Rust, which is hard to deal with right now as a beginner.
Yeah.
So how are we gonna do this? Okay. So this would be enough in other cases, by the way, just borrowing instead of owning. So this is a good start. But here, since we have a data structure where they share the same thing, the problem with this that the compiler is trying to say here is like you can't own both of them, but if you both of them borrows, then who owns the value? But yeah, it's kind of complicated actually, but let's just go to the solution directly, and I guess then hopefully I can explain it better. So because I know you didn't understand anything from what I said because I'm confused myself with what I said right now. So let's go to the solution directly, I think, because this is a hard problem, right? So not a hard for experienced programmer, but for a beginner.
Yeah.
So we're gonna use an RC here, reference counted.
Okay.
Because we want to share friends. So you know shared PTRs in C++, shared pointers.
Yeah, shared pointers.
Because
so you
we
keep
want
a reference of
exactly
how many,
we want
like,
multiple friends to own. You got the point, right?
Yeah.
So okay, so instead of a friend, we wanna get an RC friend. So reference counted friend.
Reference counter friend.
Right?
Okay.
And here you're gonna get this. So basically I'm avoiding references here. I could have used the references, but references should be avoided, especially as a beginner, because they're hard to manage. Cannot find type Rust in the scope. Not found in the scope. Cannot find type. Yeah, stdrc. So this is in the standard library. Use stdrc. Or instead of typing it manually, you could also just go into the error, control dot, and then import.
Yeah. And
there
then
you
import,
go. So, okay, now we got our RC friend, we can push it. Good. Now, actually, before we do
okay.
this, yeah, it is true that we can actually copy the friend as long as you derive copy, but you probably don't want that.
Yeah.
That's why before it
Because
tells you that friend doesn't implement copy, because move occurs because Ali has type friend, which does not implement the copy trait.
Yeah.
If you knew in C++, there is a template called trivially copyable to check if a type is trivially copyable. And basically there's some types that are easy to copy, like for example primitive values like i32, i64. You can copy these cheaply, but there is some things that are not cheap to copy, like friend here contains a string which
like
allocates,
vectors,
evic which allocates, rc allocates, and friend again allocates,
which is a struct.
right? So it's not cheap to copy, right? So we don't want to go that way. But RC, when you get a reference counted handle, this is just like a handle. It's easy to copy, and you're not copying the whole thing. So you're still referring to the same friend in memory. It's just you can copy that handle around into different.
Also, I'm guessing copy would create a copy of the object, which would mean that
You
it's not
cannot
the
mutate it.
same
Exactly.
alley object
Exactly.
anymore.
It's not the same
Like
instance
it's a
anymore.
different alley.
Exactly. So you cannot just, clone your friend.
Yeah. I wish you could.
That's why I didn't think about that solution, so.
I see. Yeah,
alright.
okay.
So this matter types expected struct RC friend. Okay, so let's make an RC out of this. RC new.
Oh,
Alex
RC new, okay.
Into. But then we're gonna need RC here. I don't think we can do this. No, of course not. Okay, cool. So RC new. Here we create a friend and we wrap it into an RC. But to create a reference count instance, right? Okay, great. Now, at David, we can give it a copy of the handle to Alex. Well, hold on a second. Well, we actually, who we want to share here for now. Let's start with who we want to actually share right now.
Ali would be the...
Yeah, Ali is the one we want to share right now. Ali is the king in town. So RC new. There you go.
Okay, and then
the
here should be
expected struct find struct what the oh yeah, my bad. I see. There you go. I thought the compiler was somehow correcting my thing. It's like, what?
How is it controlling my code?
I thought it was a new Rust feature.
Okay, so then... Oh.
Okay, we can clone this. Well, Alex should be an RC because add friend is expecting an RC, so Alex should be an RC here too. RC new Alex.into RC friend. There you go. Cool. Well, I mean, collaborative writing isn't bad in the same line. Interesting. Okay. Cannot borrow data in an RC is mutable. Data of mute is required to modify thread. Oh yeah.
I'm guessing.
As mute. Yes. Maybe. No method named as, because Oh crap! I'm gonna put you into interior immutability, which is a hard topic for a beginner. Should I do that? I probably shouldn't. But maybe we could actually. We don't have to do this, right? We can do something else, which still gonna share the same friend. It's just that we don't get into, because basically what's happening here is that RC. What is inside an RC is immutable. So to mutate
see,
it,
okay.
you have to use
You need
interior
to have it.
mutability, which is another kind of... All of this just to make sure that everything is safe, nothing gets leaked or whatever, or you don't do anything crazy. So it's all, as long as it compiles, it works. Don't worry about it.
Yeah.
So Ali, let's say something. Let's say Alex, right? Okay. Let's say Alex Ali.clone, right? So we don't mutate anyone here. We're just sharing ownership. Cannot mutate immutable variable. Cannot. Alex. Okay, let's remove Alex from an RC here. And there you go. So only Ali is RC right now because it's shared between them, right? So David and Alex share Ali as a friend. So Ali get a copy. David get a copy of Ali, and Alex get a copy of Ali. So as long as both of these, David and Alex, are there,
haven't gone out of scope.
Yeah, Ali would also stay in scope. This is why we're doing this in Rust. You cannot do that because basically here we're making sure that Ali would live as long as David and Alex, which is not right in the real life. You probably want a weak reference here because maybe pretty much, but you got the point. So what's your question?
So pretty much all of this is literally the implementation of the shared pointer.
Yeah, the RC is a shared pointer, but what is the change, the difference? I kind of forgot, I think. Yes, I think the shared PTR in C++, well, both RC and shared PTR have one thing in common, which is the ref count, right? Now the ref count in C++ in shared PTR, it's actually atomically increasing, incrementing, right? So it is safe in terms of threading. Now shared PTR would actually be better match in Rust for Arc.
Okay. Arc is something else.
Arc is basically RC. ARC. Atomic RC.
I see.
So there's one thing that a lot of there's a lot of things that a lot of C++ beginners fall into, which they hear that shared PTR is incrementing its ref count atomically, so they think it's safe to actually mutate the value that the shared PTR hold safely. In multiple threads. But no, that's not the point. The ref count is safe, right? The ownership is safe through multiple threads. But the actual value itself is not really safe.
The actual value
you have to put it inside a mutex or RW lock or whatever. So, but in Rust, you don't have that problems. RC, anything that is inside it is actually immutable. You have to either use mutable. You have to use interior mutability, which is a bit more advanced. We don't have to go through it right now.
So does that mean that, like, for example, right now, let's say David holds Ali as a friend, and Ali has a name, and it's Ali as a string. So if the Ali that David holds, you want to change the name of it, you cannot change it because it's immutable. However, if you do an interior mutation, would that allow you to change the name of Ali?
Yes, it would allow you. There's some primitives to do that. So you would have something like cell, or depending, there's a lot of other interior mutability stuff. So by just getting well, actually you wouldn't do cell here because it needs to be trivially copyable. There's a ref cell, which basically takes the borrowship rules. What is it called? Yeah, the borrowing rules at runtime. It verifies it at runtime because there's some things that you just cannot prove to the compiler that they are safe at compile time. But here though, we could have used references. That's gonna be the best. It's just that I'm actually trying to avoid references right now. but I'm gonna take them into at some point.
Yeah.
So.
And here's another question: that when, let's say, you use Interium like mutation to change the name of Ali, would the change of the name of Ali in that object have an effect on the object that Alex holds as a friend as well?
Yes, but you cannot do it in the first place because it's inside an RC.
If you do it with like cell. Or
the
other one.
Yeah, it would because it's actually the same, just one handle to the another handle to the same. Yeah, exactly. So this is actually allocated though. It's allocated in the heap.
I see.
Right, and then you just hold a handle to that heap with a reference count.
I see. Okay.
So the heap, I think, contains the reference count and the friend instance. But yeah, that's just implementation details.
Nice. Okay. That was cool.
Yeah, I'm not sure if I want to deal with references right now. Because it's not an easy topic. I mean, I guess let's try, but if it turns out that it's more complicated than I expected, then we're not going to do it. So instead of an RC, you can make this a reference. You're going to see the problem right away. Missing lifetime specifier expected. This gave me a horrible nightmare when I was a beginner. That I finally managed to understand it. Yeah. Okay. Expected friend. Found RC friend. Great. So
that would be a reference as well.
As a beginner, try to avoid references in structs. In arguments, sometimes it can still be key in arguments, but most of the time in arguments it's fine. But in structs, that's another thing. Anyways, especially when generics is being generic lifetime traits. Oh crap! Borrow data escapes outside of method. Borrow data escapes outside of method. The friend have escaped.
Escaped. Oh dear.
That's what happens when you borrow a friend instead of owning it.
They escape. Oh man.
Expected friend.
That sucks. When sucks when that happens. Friends escaping. Okay, so this wouldn't
you don't need an RC, right?
RC anymore. Yeah. This wouldn't be RC. This. Okay.
Let's remove the RC.
And we're not cloning this anymore as well. Yep. And
so now we just pass a reference here.
That's a reference
here.
Okay.
Yeah. So now we're not owning anyone. So there you go. Borrowed data escapes outside of method reference. Yeah. So let's start from the first thing here that we have a problem with.
So it says missing lifetime specifier.
I really do not know if this is going to be easy. Well, let's go with the compiler. So the compiler, well, actually run it yourself so you can see the error.
Okay. Yeah. So it says
go from the start.
Lifetime specifier. Yeah. So friends, vector, reference, friend, expected name, lifetime parameter. What is a named lifetime parameter?
So basically in Rust you have to prove to the compiler that these references, like these, what you're referencing,
they haven't gone out of scope.
Yeah, not even out of scope, but like basically they're still alive, right? So you cannot, reference some memory that is, freed already. So you have to prove it. So the first stage is to actually make a reference, a lifetime. So this is your friend's lifetime. But that means they're going to be to have the same life. Actually, no. Kind of crazy. Anyways, let's see if this is going to be easy or not. I'm kind of skeptical, but missing lifetime specifier expected named lifetime parameter. Yeah, so no, just keep it because it's pretty hard. Let's just go step by step. It's fine. Okay. It's fine for now. So what was it right now? Just go step by step because this is a little bit tricky.
Yeah, complicated. Okay.
Okay. So the thing is now when I added that lifetime, now I also have to add it here too. Oh no, this is probably not a great idea.
Oh dear. Okay. Oh geez. Oh god. Okay, so you're passing a lifetime, then you're passing a lifetime into the object of. Oh god. Okay. Yeah, I see what's going on here. Friendception. Yeah.
Crazy. Because the thing is about references in structs, they proliferate in your code base. And every time you add a reference, you have to add it somewhere else. But basically, Rust is making it harder for you to use references because they're kind of tricky to manage correctly.
So they don't want
properly.
you to use it in the first place.
It's not that, I mean, if you can prove it, sure, use it. Like, if you're competent enough to prove it, sure, use it. But if you don't, just stick with RC, arcs, etc. Yeah, I think this is probably not a good idea to make them now.
Yeah.
But I think you got the point where we're gonna need an RC.
Yes.
When we're sharing data. So.
Yeah.
Alright, so.
It is kind of interesting the way that they implemented this. Like,
yeah.
It's kind of really safeguarding everything so that you don't mess it up.
Pretty much. You cannot have like double freeze. By the way, you can't think that this is too strict for no reason. Well, let me show you something right here. So we don't need these anymore.
No, trust me. Strict is good. We want strict.
Let me just show you a little example.
Oh, jeez.
Let's say we have some vec, right? I don't know if I can actually remember this. I'll say whichever vector, doesn't matter. Right, and we have loop through this vector. Yeah, we have we're looping through this vector number in vec. And then let's just print line number. Okay, good. Okay, let's do this. This is gonna work, of course. There you go.
Yeah.
Cool. But the problem is, let's say we want to actually push while we're iterating through this vector. Push some value. What's the first error? Cannot mutate immutable variable vec.
Mutate, yeah.
Let's make this mutable. Now, borrow of moved value, vec. Value borrowed here after move. Because here we're actually moving the vector. Or consuming the vector. We cannot use it anymore. So what we could do is we can get a reference like this. Now, what we have next, cannot borrow vec as mutable because it's also borrowed as immutable. Now this is the real deal.
I see.
You know this kind of bug? Now, C++ would happily let you do this. Shoot your
it would. Yeah.
Shoot your whole foot. Actually, your whole leg. So
shoot yourself in the face. Yeah.
Cannot borrow vec as mutable because it's also borrowed as immutable. The thing is, we're iterating through the vector immutably, and then we're trying to mutate the vector while we're iterating through it immutably. So we're trying to read while writing, which is not a good idea. And as you've seen earlier when we tried it before, let's write at the same time. 3, 2, 1. This is what happens. I'm trying to write 1, 1, 1, and you're trying to write something else. It's not gonna work.
Yeah.
So it's not just a problem multi-threading, but even in single-threaded, when you have a read and a write, weird things can happen. So Rust doesn't allow you to do that in the first place. It's never gonna compile for you, unless it's used in safe.
Especially with vector as well.
Not really vector, any type, as long as.
Yeah, I know, but like.
Yeah.
At least in C++, because when you're using a vector and you're getting a reference to a vector resizes itself. So
Yeah,
the
so
reference to it
exactly.
changes as well.
Exactly. It
So
could
it's like
change. It could change. Yeah.
it could change, yeah. So it means that you could be pointing in a memory location where that is the old vector and the new
Yeah.
vector is sitting somewhere else, and now you just print the random location in the memory,
Exactly.
and then you push to a random other location in the memory.
Exactly. That's
Huh,
the main error. Yeah. That's what it's trying to.
I see. Yeah, stop you from
So here we're
shooting
borrowing
yourself in the face.
immutably, and push is borrowing immutably. So
Yeah,
no, you can only have exclusive access when it comes to mutability.
I see.
So you can either have
Oh,
one mutable reference or multiple immutable references.
I see.
So there you go.
Very interesting. Nice.
So yeah.
This has been very informative. Awesome. I really enjoyed it.
Yeah. Not Vorovik. You're still not tired?
I am getting a bit tired. So it's been like 3 hours and 10 minutes we've been
I'm not, so if you
doing
want
this.
to
So
continue, we can continue. But if you're not, you can go
I think we should call it
relax.
a night for tonight, yeah.
Alright,
Because it's pretty late.
so
And
yeah,
I'm
that was
just
a lot of cool stuff. There you go.
it was a lot of cool stuff.
Yeah.
I am probably going to like watch this literally back
Again, yeah, that's good.
and yeah, like to kind of re-implement the
Yep,
iterator
I
myself
see.
and understand like all of the things around it. That was very good. That was really
Yeah, and
nice.
I even haven't shown you
Thank you again.
libraries.
Yeah. Oh yeah, libraries as well. True.
Let's just show
Okay.
you a little bit of libraries, and then we're gonna go, pretty much.
Okay.
And just
Sure.
how to add, a simple library, and that's it. So you can
Mhm.
explore it yourself then.
Yeah.
So, and show you how easy it is compared to CMA. Let's
Mhm.
say we want a library,
Oh god.
like, basically, let's say you want to add some big numbers, right? So,
Okay.
I don't know.
That is the big number.
I don't know.
Oh jeez.
On ambiguous numeric type integer, yeah, fine. 32, I guess.
I think you would probably need U128.
Okay. There you go.
Ah, there we go.
Let's see if this would actually do what I'm expecting it should do, or if I need some more power. Okay. There you go. Thread main
Okay.
panicked. Attempt to multiply with overflow. So
Yeah.
numbers aren't like Python, they're not infinite.
Mm.
So how we can
Yeah.
fix this? We can use the library.
Oh.
Big int rust crates. Or we could look up the rust crates, right?
Mm-hmm.
Look for some big integers. Make sure it's, oh crap, almost 4 years ago.
5 months ago.
No,
That's
this
not
is
bad.
common. Where is the, I think it's this one. Yeah, this one, I think. Num big int.
Okay.
Yeah, this one is good, I believe. So we could just copy this command, go here, paste, done. That's it. I added a library right now.
Wait, is that now part of that cargo TOML? Oh yeah, it is.
Exactly.
Dependencies num big int, yeah, 4.4.
And I have an extension that tells me is it the last version or not.
Ah, nice.
There you go. That's how you add a new library. It's that
Oh
simple.
my god. Please, somebody make this for C++, please.
Okay,
Oh,
so
dear.
how we could use this? Well, documentation. So Remember when I told you that we follow the same conventions and stuff? Well, even our documentation is always the same.
Okay.
Style and same everything. So you see this documentation? Let's see some other library.
Yeah.
Like in algebra, this is
So
another.
it's essentially of type.
This is another library that I love in Rust. It's for algebra. So this is the documentation. Isn't it the same thing? Well, hold on.
Yeah, it is. Yeah, true.
There you go.
Nice.
Reason
Very cool.
because documentation is embedded into Rust itself, so you can generate documentation easily.
Like similar to Java docs.
Yeah, exactly, but nicer.
Yeah. Nicer, yeah. It does look a lot like nicer.
Replace the by the latest. Okay, anyways, let's go back to this. Oh, not this one. This one. Right, now big int. So let's see how we could use this. Let's go to the documentation. Okay, so big integer types for Rust. A big U int is signed represented as a vector of digits. A big int is signed as a combination of big U int and sign. Common numerical operations are overloaded, so we can treat them the same way we treat other numbers. Traits coming into handy. You can actually have operator overloading in Rust by implementing a trait. You implement add. That's generics. That's another video by its own. So anyways, calculate large Fibonacci numbers. There you go. This is how to calculate large Fibonacci numbers. Big U int. Oh, well, it's using generics, or is it? I mean, not generics, but traits. Okay, I see.
Yeah.
I see. Yeah, there's a lot that I didn't show you, but anyways, this is fine for now.
Would this now let me to just say let x
equal to
of type
or yeah, go
int and then equal to this number?
But this operation is the one that overflows, so you gotta first of all start with making the operand a big U int, then doing the operation.
Okay.
So before doing POW, you have to somehow convert it into big U int.
Oh, I see.
So remove the POW for now. Cut it. Yeah.
Yeah.
Now how do you convert this into big U int?
But into?
Try.
Right?
Okay.
I'm guessing. And if I like, oh wait, it says cannot find type big U in this scope.
Yeah, because you have to import it. Control. Go on.
Oh yeah.
Control dot and try to import it, I guess.
What?
Did he give you some suggestion?
No, it doesn't let me. No.
Let's see.
I think it's that thing.
Oh yeah, it doesn't. So just go to the documentation, check it out. So here, you just copy. You see, you click on this button right here.
Oh yeah.
Use.
Yeah.
There you go.
Ah.
Rust Rover, for example, it was that smart to actually do it for me, like to suggest me to do it, even if it's another crate. But anyways.
So if I do mod and then I do x equal x dot pow two. Not there. Jesus. And now do x. That should work.
Try.
R go R.
There you go.
Okay. Whoa.
It's that simple.
Okay. Huh. Interesting.
So you see, you already figured it out yourself. You didn't even have to check the documentation to know what to do. How I gonna convert this into simple? Let the compiler does it. That's it.
Yeah. Wait, what was the other thing that you had to say what to convert it to? Oh, from.
Yeah. You could say big U int from. Big U int from.
Oh, okay.
So instead of doing this, you could just say big U int
Yeah,
from, yeah.
I see. Okay.
So that's how you add on your library,
Yeah.
pretty much.
That's pretty cool, to be honest.
Yeah.
I wish C++ was like this. Now try adding SDL and Vulkan to C++.
So,
40 minutes video.
yeah.
Yeah. Awesome.
All right.
That was very nice. That was actually really fun. Like, it's a kind of language that you know you're going to be like, I don't know, what you're making at the end is gonna work.
Yeah, pretty much.
It doesn't let you. Yeah.
Especially in multi-threading and when it comes to async. Oh crap.
Oh, yeah.
So yeah,
Oh dear.
that was it for the stream, I guess. That was 3 hours.
Yeah. Thank you very much. It was really nice, like, I don't know, chatting with you and also getting to learn Rust. And I can finally, well, to be honest, this is a good way to just kind of get a start. And now
Yeah.
I kind of know how to go about do it myself from now on.
Yeah, pretty
Because the
much.
compiler is just, goddamn, compiler is so good.
Yeah. Let's go.
Yeah. Awesome. Thank you so much for having me here.
You're welcome. Anytime.
Yeah. Hope to see you do this more often because this was fun, and
Yeah.
I'm sure like
we may even do
whoever
a follow-up
comes in afterwards-
session, or I may
Yeah.
go with some other people. We'll see.
Yeah.
We'll see how it goes.
Yeah.
So yeah, that
All
was
right.
it for this
Cheers.
stream. See ya.
See ya.
Alright, everybody. That was it for this stream, and see you later. Goodbye, everyone.